How exciting! It's day 2. We're ready to go. Good morning. Good morning, Lisbon. Okay. I hope you had a nice evening last evening. Sampled some of the delights of Lisbon. I was quite well behaved in order that I could be fresh and bright this morning. We walked up the hill today, so a little hill climb, that was good. Main things. One thing I do want to talk about, I think, is actually the design language of the conference. We go probably to a lot of events, and you think about swag. You've all got swag that you get, and you immediately think, why have I got this? Like, what am I going to do with this? I'm not going to wear this t-shirt. I'm not going to use this bag. Or just the website doesn't look that great. That is not the case. That is not the case with Lisbon AI. So I think that Anna and Isabel have done an amazing job and deserve did the design, built the website, and I think the digital experience has been great, but I think overall just the design language is really appealing. I know when I stand up here, I feel like, yeah, this is amazing. So I just think that's so important, and yeah, like I'll be, we live in a world of many, many, many jute bags, canvas bags, and this is the one that I'll be putting my wine bottle in. So thank you, amazing design work. I think the organization, and I'm not one of the organizers, by the way, so I can say this has been flawless. So again, thanks to the organizers. I did the whole list of sponsors yesterday. I'm not going to do that again. But do take the time to just go and hang out, talk to the sponsors. The thing about independent events like this, and here, the sponsors, right, they're sponsoring an experience. We haven't had talk after talk, which is a shitty talk by a vendor that bought the slot. Like, the sponsors here have sponsored your experience. And I know from my perspective, I much prefer indie events. I feel very, very comfortable with this. And we will go to the vendor events where it's just, pitch after pitch after pitch, and that's not what this conference has felt like. This is much more collaborative, and so therefore, yeah, do some commercialism. Go and talk to the sponsors during the breaks. So yesterday we talked about platforms. We talked about robotics. And then in the afternoon, I think we had a lot of fun going a little bit deeper with some of the tools. And so today, one of the things that we have been missing in terms of the to make a pun, I guess, the foundations of what we're doing is foundation models. And so I'm super excited about the topics this morning. So Noah Solomon did an amazing talk yesterday about whimsy and the importance of whimsy in experience, right? And, having a model sharing platform could be kind of like dull. And I think that one of the things about Hugging Face is they brought all of us like a smiling, happy face to the idea of models and how we can interface with these models. And I think that's, I think in tech waves that can be like with containers, Docker did such a good job of humanizing technology. Because at the end of the day, the tech is cool, but if we as humans don't feel good about it, we're not going to have a great experience. So yeah, naturally, I was excited. We have a speaker from Hugging Face, and I would like to introduce you to Dana Orbik-Karova.
Hello, can you hear me? I guess you do. Hello everyone again. So thank you very much for inviting me to Lisbon AI. It's been a pleasure for me to be here yesterday, and I hope you will enjoy your day today. Today I'm going to talk about democratizing AI for robotics with Small VLA. Small VLA is a foundational model built by Hugging Face and the robot, where I was one of the leading authors. And I will be speaking about how we build this model, how, in general, what is VLA? Probably many of you might already have heard about VLAs, but I will still remind you what is it. And I will try to include all necessary links, QR codes to the essential references, so feel free to scan and just look for more information there. So shortly about me, yesterday I tried this AI photo booth and it was a very nice experience, so I advise you to do it today if they will be still there. And so I am currently a small VLA lead at Hugging Face, and I graduated from a French École Normale Supérieure, Paris-Saclay, and it's essentially like theoretical machine learning master's degree. And then I joined Hugging Face, and since then I'm just passionate about open source robotics and currently building foundational models for robotics. So let's jump in. Firstly, let me introduce you to what is Le Robot. I guess that's the main product people know when they hear about robotics from Hugging Face. This is the platform that provides models, data sets, tools for real-world robotics. And it's built on top of PyTorch, and it's just aimed to lower the barrier to entry robotics, and essentially everyone from any background, no matter whether you have master's or bachelor's in robotics, can actually just try and play with this library. And even the hardware that we are trying to provide, trying to give the code to use the hardware with, it's very cheap. So, for example, one set of arms costs you 300 euros, and I think it's quite cheap to start doing something in robotics. So, as I said, we provide policies as well. It's AI models for robotics. Here, on the video, this is the policy of state-of-the-art model in robotics, and the model from which everything has started. It's called ACT, Action Chunking Transformer, and then we also have more than 22,000 data sets stored on the Hugging Face Hub under the tag Le Robot. You can see all these data sets. And some of them were published by big companies like NVIDIA and Physical Intelligence and other startups in robotics as well. So, and also we provide tools to deal with this data sets. As you can see, this tool was built with one of our community members, Alex. We use this tool in order to build the data sets, pre-training data for foundational model that I will be talking about later. Why do we even care about robotics and democratizing robotics for everyone? Because today's robots are very narrow specialists. They are a bit hard-coded and they perform repetitive tasks, and real environments are very complex to automate, so you cannot just continue automating tasks because the tasks are different, real world houses, they're all different, and we cannot generalize with one robot that was automated to one particular house and one particular task. So, and also we have very small effort in diverse pre-training, but I think that's changing. Like with every year, you can see many VLAs appearing, and they are almost on par with LLMs right now. Almost second paper that is being released is about VLAs. So, and also we want to explore the power of fine-tuning for VLAs. We can actually outperform some narrow specialists by transferring knowledge across the tasks. So what do we want? We want the robot to follow naturally instructions, task descriptions, let's say, like bring me a cup of tea, for example, and then adapt these robots to different environments. And we also want to, ideally in the future, we want them to learn new tasks just from minimal amount of data. And then we want a highly scalable architecture. And the problems that we have currently is that we have varied robot embodiments. Each robot, let's say, ARM or Unitree, for example, or Ricci robots, they all have different configurations, different degrees of freedom, and then, which is like just the number of proprioceptive actions and states, states and actions. And so that's why we have also varying input size. And it's not very scalable because we don't have ImageNet for robotics for now. And then also it's not very generalizable. It's overfitting to specific tasks, environments, and objects. And we struggle with some unseen instances as well. let me just now start explaining what is small VLA and how to build it. As I said, there is a QR code to the paper or blog post, I don't remember, but you can find all the essential assets by scanning the QR code. And so the input to the foundational model in robotics looks like this. So we have text, vision, states, and actions. Text, as I said, just like the natural language instruction, typically consisting of one task without any hierarchical tasks, compilation of tasks. It's just simple ones, pick up the yellow block, but I think many people right now are trying with more complex tasks involving some subtasks as well. And then video frames containing multiple viewpoints. That's the vision input that we pass to the foundational model. And then states, as I said, they capture a robot's current physical configuration, joint positions, and effector pose, and gripper status. And also we have actions. It's just target robot action representing what robot should do next. And depending on the robot type, we have different dimensions for actions. For example, the robot arm that I mentioned in the beginning, which is like very cheap, 300 euros, it has 6-dimensional actions. So in the end, we will predict just 6-dimensional output. This is a typical VLA architecture. I just simplified it massively here. So you can have like images, tasks, and robot states as an input, and then you pass it to some pre-trained VLM. I hope, VLMs are quite also popular. Probably you heard of them. It's just vision language models. And then in the output, you get action decoder. And then you pass the outputs from VLMs to action decoder. And I guess the action decoder is the key component in the vision language action models. Let me just briefly explain how does it work. Please stay with me. It's not too technical as it might seem. So we just predict actions based on the previous observation states, observation frames. It's just previous, the combination of everything, the multiple viewpoints from different cameras on also text and proprioceptive states. It's all observation vector, and then we predict based on this observation vector the next actions. And then we just use flow matching loss. Basically it was adapted from denoising architectures, and it works for robotics as well. So as you can see, the objective is to model the probability distribution of actions given the particular observation state vector. And so as you can see, I think I just put some more details in the action decoder part. You have cross and self-attention. Normally it consists of self-attention. That's just the typical architecture for vision language action models. Maybe you've heard about physical intelligence, and their first model called Pi0 is based on exactly the same architecture. And now let's come to more specifically to small VLA architecture. We didn't go very far. We just adapted the same architecture. The main modifications, I have shown them on the slide. We just used layer skipping in pre-trained models because they have been proven to be very effective. And we don't use all the layers from the pre-trained VLM models, which in small VLA, we reduce them by half. Every second layer we would skip. And also another key thing is just we replaced we interleaved cross and self-attention, because in Pi0, for example, they used only self-attention. So that also helped a bit. And the key component probably is the data set that we use for pre-training our foundational model. So community data sets, this is the performance of small VLA in real world. I don't know why the last two videos doesn't work, but it is like during inference in evaluation. So that's how the model performs. The task was to pick up the cube and put it in the box. That's the simplest task. And then we can see that it also generalizes on a slightly different environment. This data set was not present during pre-training and fine-tuning as well. So next block is community data sets, and I guess we are moving to the key part on how to build community-driven foundational models and why do we care. So there is like data islands problem that was described by NVIDIA in one of their papers. The paper was called GROOT, and they said that mostly robotics data sets, they have a form of data islands. Like since we have many embodiments, many different dimensions for actions, they are all split in the form of archipelago of data islands. So we have like a large island consisting of, for example, the data sets with 6-dimensional actions, and then there are other small islands with some very interesting but like particular robots that are not so popular. So this creates problem that we cannot really build a general model that can capture all these robots because each of them has different configurations. And so we need something, a robotics equivalent of ImageNet, the data set that will ideally capture all these robots, as many robots as possible. And then also we need to have architectures that can work on cross-embodiment data. So if you imagine these islands as embodiments, cross-embodiments, I mean like just taking all the islands, regardless of the size, into the foundational model. And shared formats, annotations, and infrastructure, that's what we also need. And also, if you are wondering how to record a data set in robotics, it's a bit different from just data sets in images for image models or language models. We also need to include the feeling of the robots, basically the physical space. So, and I used to provide this example, the favorite example from one of my colleagues, is like, it's equivalent to playing the football. You can watch the game, you can understand the strategy, you can spend endless hours just watching, but we will not really get the full experience by not trying and hitting the ball with your feet and not going to the field. You cannot experience this, so we need to sort of incorporate the physical experience of the robots that they have. And we do that by teleoperation. That's how we collect the data set. It's from my previous talk. I showed how the data set is recorded. So you have the follower arm and the leader arm. The leader arm is the one that I'm holding, and I'm sort of trying to manipulate the arm by just moving the leader arm. But the follower arm just repeats after leader arm. So that's how we collect the data for robotics. And so what kind of efforts we are doing to accelerate the ImageNet of robotics? We simplify the data collection, the tools, and in order to use this leader and follower arms, you need to have clear tutorials, you need to have configurations, and we all do. We have this in the robot, so you can easily just follow one of the tutorials. It's quite easy to follow and understandable. And then we standardize formats. We make sure that the data sets that are already present, they have a single format, so that you can just use our tools irregardless of where the data is coming from. And we also enable sharing through the Hugging Face Hub. And and basically we motivate community contributions. Anyone can push and collect the data. So there is a nice blog post that we read with community members. You can see Will as well. He was talking yesterday. And so we just made this blog post on when to expect ImageNet, if you're interested. So this is the robot community datasets. I think this is not updated. It was almost half a year ago. 1.5 years ago, and as you can see, the data sets has grown significantly during 1 year. So that's all the data sets that we used for pre-training small VLA. It was also prepared by Will and Alex, I think, the visuals. So this is the recent breakthroughs in robotics by Hugging Face. We recently organized a Robot Worldwide Hackathon where we had, I don't have exact statistics, but we have many contributors and many local instances all around the world. On the map you can see where the hackathon took place. It was a decentralized hackathon. We had online participants and also some offline participants in each city. and like everyone was given a task, and they were trying to build with using our Le Robot tools. We even identified some winners. I don't remember. I think there was 30 winners. Like we watched each video, demo video that they sent, and here's some creative videos. I think they, as you can see, they used small VLA and they used also ACT. And for example, in this video, the person is just trying to train the model in order to put corresponding figures based on the color that it's seen in the screen of the phone. So when it's blue, it should put the blue disk and etc. And there is also another one which is very interesting. It's called Le Chef, and they build this pipeline based on ACT. Yeah, so basically the robot assembles a sandwich based on the products, and it's all it's not an automation, it's AI. So they train a model in order to teach the robot to grasp the object and put it on the bread. So yeah, they also provide some details on the architecture here. And this one, I guess, also they trained this model on small VLA. It just shows the precision of actions, just to put screws in the, using screwdriver. So it's actually very impressive because for robotics, and especially when using not so affordable, not so expensive hardware, we do have lots of jitter and unnecessary stuff related to hardware. So it's hard to get the very precise output. And also recently released Richie Mini. It's a cute robot that was developed by Poly Robotics that Hugging Face acquired recently. So it crashed the internet, I guess, I would say. We had many pre-orders. We even had to make a negotiation with Seed Studio in order to produce these robots because they were in such a big amount that we did not expect, and we needed to have manufacturers for this. So yeah, it's just like a personal assistant. You can train models using the hub and then teach your robot to do something like maybe recognize gestures or do some voice assistant from this. I think it has multiple use cases. And also, just to finish my talk, I wanted to say that I've been receiving a lot of questions on how to pre-train VLAs and whether they can reproduce small VLA by using the paper and the code at Le Robot. It was a bit hard because it was a bit researchy and we did not really clean it properly so that people were ready to use. But now I'm working on developing a framework for pre-training VLAs so that people just can follow the simple README file on GitHub and just reproduce the training, given that we also provide the data sets. So if you have compute, if you have clusters, and you just don't know from where to start, I think it would be a good point, and it will be called VLab, like standing for VLA Lab. And so we are releasing it soon. Stay tuned, and I hope you will find it useful. Thank you so much.
Dana runs at a higher clock speed than me, that's for sure. That was a lot of detail. Do you mind taking a couple of questions?
Yeah, sure.
Great. Fred, question?
Good morning, and thank you. So we're starting to see a bunch of people work on world models, and so generating worlds that then people can interact with. Do you see a world, I guess, where we can start to merge the two initiatives, where robotics actually learns from that type of effort, or no?
Yeah, I think it's a bit hard, but yeah, I've seen lots of papers on world models, and many people are asking. But I think before that, we need to close sim-to-real gap, because it's a bit hard to right now generalize in the real world. It depends on the task you want to solve. If you want to solve some actions in simulation. Probably world models would be a great addition, but right now it depends on what kind of data will be generated, whether it's really very realistic and very close to reality, or if it will look like a very close to reality simulation environment. Then I don't think it will be very useful when it comes to transferring these policies into real world, because even the very realistic simulation environments, they don't really look like a real world. But of course, if world models will solve this problem, then why not? Because as I said, we have a lack of data, so it would be nice to see. I hope I answered your question.
Any other questions for Dana? Okay, well, we're going to crack on in that case. Thank you so much, Dana. But yeah, no, seriously, I think I talk fast, so that was something. Sort of robots, how they interact with the world. We thought about that. As humans, obviously, one of our absolutely primary communications modalities is voice. And in order that AI begins to infuse everything that we do, a big part of that is going to be voice. And so a tool I recently, because for me, I'm always interested, when does a tool change your workflow? And I was a little bit blocked on some writing, and I started to use a tool called Whisperflow, and I just found it worked really well for me. And it's kind of nice when you feel blocked, and then you find that you're writing or speaking. And so, yeah, I think there's a lot of opportunity here for us in terms of changing the workflows. And a company that's working on voice and AI is 11 Labs, and I'd like to introduce you to Angelo Giacco.
Hello, everyone. Oh, awesome. Yeah, awesome. Thank you very much for having me. Unfortunately, 11 Labs, we're not quite as open source as Hugging Face. So there are some things I can't go into today, but I'll be happy to talk to you in private afterwards if there are any kind of like specific questions you have about model architectures and stuff. In general, my plan is going to be to try and give you a quick taste of the state of audio AI for the next 15 minutes, and then I'll leave it for like 5 minutes of questions. I'm going to be doing multiple demos. There's like one in particular I think has like a 5% chance of succeeding. So bear with me if anything goes wrong. But yeah, let's take it away. 11 Labs, we're a foundational AI research and product deployment company. This means we do like AI audio research. So our goal is to become the voice of technology. So we do research on text-to-speech models that can generate human-sounding speech. And we also do research on speech-to-text models. And from that, we've built like a couple of platforms. So we've built the creative platform, which I'll show you in a second, and the agent platform, which I'll be demoing. The thing like I really want to drive home is like audio models are very hard to get perfect. And when they're not perfect, like it's really, really painful. Like if the audio you hear sounds a bit not human, like you detect that straight away. Whereas if what ChatGPT says is like slightly wrong, you'll just read it and think it's some garbage, but it doesn't pain you in the same way. And the other thing I want to drive home is like foundation models for audio have the same kind of scaling laws as like LLMs that we've seen, whereas those scaling laws like on this vertex of kind of intelligence. The more you scale them, the more intelligent they are. With audio models, the more you scale them, like the more controllable they become. You don't necessarily get like more intelligent output, obviously, but you have more control over that output. And generally, like 11 Labs as a company, at every step of the way, we've run into problems. For example, when we first created our text-to-speech model, there weren't enough voices on the platform, and so we had to create like a new AI model that would generate voices for our AI model that generates speech. So yeah, at every step of the way, what I'm going to try and show is that we've had to build our own AI models, and I'll try and talk a bit about them. So yeah, everything I'm going to show you today, I'll mainly show it via the UI, but it's completely API-driven. I initially started as like a developer relations engineer working on these APIs, so everything is like completely open. I'll just demo it in the UI for like simplicity. So how do we get here? 11 Labs only started like just under, well, almost 2 years ago now. In that time, we've scaled to $200 million in revenue, on track for $300 million by the end of the year. And every year, we've had some kind of like step change research unlock that has helped us move to the next level. So we started with our TTS in 2023. That's just simple text-to-speech in English. By the end of that year, it was in 8 languages. The next year, we followed on with PVCs. PVCs are just like an API for creating LoRa's on top of our TTS model, so that you can like clone your own voice. And I'm going to try and show that live in a second. We then created a dubbing pipeline, so it would transcribe the speech that's being spoken, pass that into an LLM, translate it, and then use our text-to-speech to dub it. And then we created text-to-voice, as I mentioned before. And then this year has been an incredible year. We have created the world's most accurate ASR model, which I'm going to show you in a second. We have created the text-to-speech v3, which required a completely different architecture, which I'll talk about a bit. And we've created our first music model, which was done in partnership with artists. And yeah, I'm going to try and demo these live now. Wish me luck. So let's zoom in a bit. So like this is just like the basic text-to-speech model. This is just like our V2 model. You can imagine we created a large data set, and then we have a specific kind of transformer that works on speech templates. Speech templates are just kind of blocks of audio that are converted into a waveform that our transformer is trained to generate. So this is what V2 sounded like. I'll show you a second.
Hey, Lisbon AI, it's great to see you all.
Okay, so it kind of like sounds human, but when we jump to V3, the V3 model has like, on top of the existing text-to-speech architecture, it has kind of like a side architecture, which is a natural language understanding component. So you can imagine it as some kind of transformer that's attached to our text-to-speech model, which allows it to have much better emotional understanding. So already the speech it will generate is probably going to sound a bit better.
Hey, Lisbon AI, it's great to see you all.
But on top of that, because it understands natural language, what I can do is give the agent, give the voice model some prompts of how I want it to say stuff. So I could add in here like it laughs, and it's maybe here it's excited. And because the model has like some natural language component that understands these tags, it's now going to completely change how it generates the speech. Let's try this one.
Hey, Lisbon AI, it's great to see you all.
And the really cool thing is it understands like basically everything. So I can put in here something like an air horn, and it will understand sound effects. So if I try this, it doesn't always work. So let's pray to the gods.
Hey, Lisbon AI, it's great to see you all.
I love it when that happens. When it works well. So like it has this kind of architecture that is able to understand natural language. You can even get it to do really cool stuff like switching accent. So if I maybe change it to like French accent, like I'm in Paris now, I don't know, something random like this. The model kind of has this really good understanding of the natural world, like any ChatGPT LLM would.
Hey, Lisbon AI, it's great to see you all. I'm in Paris now.
Okay, it wasn't great, but you can get it to try all sorts of different prompts. And yeah, like we're really excited to see how this evolves. I'll talk a bit later about how we've seen this in action with like certain video games, but it really adds like a level of emotion to your voice model, where if you want to create a game, you want to create a movie, you want to like translate your movie into another language, it really like just like it sounds really emotional and human. We also have like the best speech-to-text model on the market. So today, we're actually launching Scribe Real-Time V2. Scribe is our industry-leading speech-to-text model. The really cool thing about this model is that it's able to use the same kind of audio tags as we have in our text-to-speech model. So not only does it kind of transcribe the context of the conversation, but it will transcribe these kind of like audio tags you see here, which are the same audio tags that our text-to-speech model understands.
Ready again?
So here you can see it's like categorizing which speaker's talking. Maybe if I start it from this bit here, You can see they're all talking over each other. The model understands the different people that are speaking.
Well,
I'm mainly here just to learn from Stan. That's the reason I'm here.
And you can see like it's also transcribing the kind of the fact that they're laughing. This can be super helpful. If you're like trying to create an agent that is talking to a customer, you actually do want to understand if they're laughing or they're sighing or they're doing all these other kind of contextual things that an LLM can understand. Let me just check time. The other really cool thing I wanted to show you is that kind of our goal at 11 Labs is to become the voice of technology, to create the best text-to-speech models, the best speech-to-text models there are. We actually found, like just purely by chance, by trying to make these models that understand emotions, that understand different cultures and languages, that we could create like music models. We got it completely for free. We didn't know it would happen. So I'm going to grab a prompt. Wait, no, let me grab my notes. So I've created a prompt here. It's like create an intense, fast-paced electronic track for a high adrenaline video game, and it's going to start by saying, welcome to Lisbon AI. We found like the same model that powered V3. We could give it a prompt like generate a song, give it that kind of context, and it would generate, using kind of basically almost exactly the same text-to-speech model, it would just generate music. And this might take a second, but in a couple of seconds we can see how that works. So I've given it that prompt. It's automatically generated like some styles to include, and we can start listening to the music. Sometimes it's not great, but let's try it.
Welcome to Lisbon AI.
Okay, I think these demos are going great so far. This is great. Yeah, so this is basically almost exactly the same architecture as our text-to-speech model, just kind of fine-tuned with some prompts to generate music, and it's able to generate like a pretty good waveform, which sounds like, I mean, I could dance to that in a club, right? So, yeah, it's pretty cool. The other thing I wanted to show you is this bit here. So we basically have audio models that generate and understand human speech. They are like customizable, enterprise ready, whatever. This is a sales slide, but they understand context and they're able to talk to you in a very human way. And so what we saw a lot of our customers doing was using this to create video game characters. So for example, Fortnite deployed Darth Vader into Fortnite in a way that people could talk to Darth Vader whilst they were playing Fortnite. This looked like this.
We go north, east, or west to find more enemies.
Enemies will come, Lackwit. However, a direct path north presents the most immediate access to Foxy Floodgate. Are you questioning my tactical assessment?
Okay, well, Darth Vader just told me to go over to Foxy Floodgate.
Okay, so you can create really cool immersive game experiences where you're like talking to models. This is powered by 11 Labs that's transcribing the speech, it's understanding it, and then speaking back to you in like a funny way. It had like dynamic content and everything. But the really amazing thing was we ran this event for 3 weeks with 0% downtime. Our GPUs were running the entire time. Every single second for those 3 weeks, we were generating 2 days worth of audio, which meant that we generated 56 years of audio in that first week of conversation. And we were like, our GPUs were running with requests of 9,000 requests per second with 0 downtime. So like, if that's something that interests you from an engineering point of view, like, come talk to us afterwards. We're always hiring. And then we thought to ourselves, like, as a foundation model company, it is really hard for us to make money with like the amount of utilization of our GPUs. And so we thought we would make an agents platform so that anyone can create an AI Darth Vader. So what we did was we created an agents platform. I'll do this here. So this means you can come into our dashboard, you give your agent a system prompt and a first message. Here, like the first name is dynamic. And then you can talk to it with the 11 Labs models. So if I try it here.
Hey, Angelo, the coupon for participants of Lisbon AI is Lisbon AI, all in capitals.
Hey,
Great.
Can you tell me something cool about 11 Labs?
11 Labs is known for its advanced AI voice technology, which can generate.
So there I've generated like a version of something like Siri that I can completely customize to have my own like business context and everything. And it's completely like very simple to deploy. You need one line of HTML and you can add it to your website. Or we have SDKs, like I work on the SDKs for WebRTC or like a WebSocket SDK. They are across like all the platforms you could require. And so this is like the bit of the demo that I think is probably not gonna work, but we can give it a go. And if you want, no pressure, you can scan this QR code and submit your phone number, and the agent will call you right now. I'll set that up in a second. Okay, we are going to demo this next week at a summit with 500 people. So I'm going to try it out now. You are all my guinea pigs. So yeah, basically we have built these agents that are able to go over the phone. So if I get the submissions. Oh yeah, your phone number may briefly appear on the screen. So please don't kill me. All right, it seems like we have 10 people so far. Refresh. Oh, 26, nice. Okay. I'll give it 2 more seconds. If you want to put your phone on, like, take it off silent, it'll be quite funny to hear all the phones start ringing. Okay, I'm going to download the CSV. Now I can, like, come back to my dashboard, and I can do, like, this outbound call. You can see all the tests I did last night. And I'll create a batch call. Let's do Lisbon AI live. I'm going to call you from this phone number here. You'll get a call from an American phone number. It's going to be the Lisbon agent. And let me see how this goes. Okay. Hopefully phones start ringing soon. Ah, fuck. Okay. Nice. Okay, cool. Well, it seems like the demo needs some work, but yeah, that was it from me. Yeah, if you have any questions about audio AI, I'll be happy to answer any of them. And yeah, thanks a lot.
Well, hang on, because we'll take a couple of questions now, if that's all right. Hey, Lisbon AI, it's great to see you all. Anyway, any questions for? Is he going to take my job? I think that might, maybe we don't need James anymore. We'll just have 11 labs on stage. Question.
Hi, great presentation, great product. I was wondering, how do you handle regionality in speech?
Yeah, that's a really good question. So we have a few things. So
in fact, can we see the Portuguese accent?
Let's try it.
Come on.
So wait. Yeah, so I chose a voice specifically for Portuguese, which hopefully should sound better. So we have this like Patricio voice. I don't know if it's good, but it sounds like
Olá,
this.
eu sou o Patrício. A minha voz é ótima para ser usada para português de Portugal.
It's getting the nods. It's
Podcasts
getting
ou
the nods. There you go.
Nice.
There you go. You needed to do that in the demo to start with.
But we also have like a way of remixing voices. So if you find a voice you really like, but it's not got like the Portuguese accent you want, we have this tool where you can go in and say like, make it have this specific accent, and you'll have like the same voice but like remixed slightly. So
is the Northern Portuguese accent different? That was already regional. Ah. Yeah.
French, German, English, right? And do you account for all of these? And then you have sub-regions inside the country. But I wasn't even considering that.
Yeah, so our model, like, it handles Portuguese and, like, there's, like, Portuguese is a very big one, so it handles Portuguese and Brazilian Portuguese differently. But, like, generally, that's just because, like, Portuguese is so big. Whereas something like Swiss German, it's just handled as German. But, like, the V3 model, if you prompt it with a specific regional accent, it does it very well. Like, I'm from Sicily in Italy, and if you prompt it, say, like, Sicilian accent specifically, it does it quite well.
Definitely not sounding Sicilian now.
Lived in London too long.
Question there at the back.
Yeah, hi, thank you so much for the demo. I'm interested in the music model part. Do you plan to give the artist a way to fine tune the music? Because like I saw that you had arpeggios and stuff and it was a little bit heavy. For example, I've tried A-step, diff rhythm and all this stuff, and the problem that I have is, doesn't matter how good you prompt it, if it doesn't know this specific subgenre or something, it's very hard to reproduce that. But with MusicGen, you can actually like fine tune it. But if you do continuous generations, then you start seeing noise and stuff in the audio. Is there any ability or like plans to do that?
In terms of like giving a single artist like a fine-tuned model, that's very expensive. I mean, it's possible we'll do that, but we haven't talked about it yet. We want to give artists more control, so we already have just launched, I think today, stem separation, so you can like prompt the different stems, and like in painting, so you can say, you know, this song is perfect, but like seconds 10 to 15, you need to change this. So definitely want to give you more control. Fine-tuned model, like, I think it's tricky, but maybe. Do you have time for a couple more?
There we go. These are the last two, so we'll start with you.
Good morning. Nice talk, by the way.
Thank you.
Question, just follow up on this artist question. Is it planned in the future, like fine-tuning, really expensive? Artists have samples. Can you throw some samples the AI way and it uses those?
Probably, I think so. Like our text-to-speech model, you can like prompt it with kind of 10 seconds of context and like say, carry on with this kind of voice, but generate this text. I think probably the music model can do that. I don't know the music model too well, to be honest. But given it's kind of the same underlying architecture, I'd say probably.
Yeah, one last question.
Thanks. This probably touches ethics already, but is there any work towards generating particular voices, like, I don't know, for relatives or for whatnot? Can I train a model sounds like me or someone else?
Yeah, like voice cloning is how we became popular in the first place. Like you can add 10 seconds of your voice or 2 hours, and if you give us 2 hours, we will fine tune a LoRa, like an adaptation on top of the model. If you give us 10 seconds, we'll add it as the prompt I just mentioned. We do have like safety features as well. So based on that, we create an embedding of the voice, and we can check if it's close to the embedding of some famous figure. You have to do like a capture verification, and we also do safety checks, right? So if you're generating text-to-speech, we can do safety checks against the text you're generating into speech and see like, you know, is this like some kind of malicious or non-safe generation? Yeah, we have a safety team that does that.
So I said that's the last question, but maybe just one more. Everyone seems to be having fun, so let's roll with it. One last question? One last question? We said we'd have one.
Thank you. Thanks for the talk. It was great. I was really captured by the idea of music being an emergent property of the model. Are there other emergent properties you have found in 11 Labs in text-to-speech? I'm curious about that.
Yeah, actually, I don't have time to show it, but we have like a sound effects model. So instead of just like prompting, generate some music, you can say like generate a sound effect. Then you tell it like make the sound of a plane taking off, and it will generate like a 20-second clip of that. I'm trying to think if there are any others. I think generally that's it, to be honest.
Okay, there we go. Thanks very much.
Thank you very much.
So yeah, names, this question of voice, AI, but names can certainly be a minefield. You never quite know how things will be pronounced, even when you think you do know the answer. And, you know, when you see a very English name, I think, well, I definitely know how to pronounce that. And in fact, we spoke about it before our next speaker. And then I suddenly realized, oh no, we were so busy joking about the fact that I could pronounce his first name, but I hadn't disambiguated the second half. So yes, this stuff is not always easy. Anyway, our next speaker from Poolside, and this is an interesting, this transition from artisanal to industrial. I think we're all a bit worried about that. As software developers, you know, we think of ourselves, many of us think of ourselves as craftspeople, moving to a more industrial world. So I'm certainly looking forward to hearing a bit more about this. And I'd like to hear introduce from Poolside, Joe Rowell.
First of all, I'd like to start by saying thank you all for having me. This is a great pleasure. And I want to sort of frame the talk that I'm going to give a little bit. So James earlier mentioned that this session is about talking about the foundations behind the applications that we heard so much about yesterday. This talk is about the foundations behind the foundations. So what I'm going to talk to you all about is how we build models at Poolside. So the entire process from taking a data set the whole way through to the end of actually getting a model that we can use for things. You've all heard of us, of course, because we're one of the sponsors, but I just want to give you more context on who Poolside is. So we're a company that's pursuing AGI via the medium of software development. So what that means is that we write models, or we build models, that are designed to be good at coding tasks, essentially. From as simple as generating unit tests or things like that, through to essentially end-to-end application development. That's really what we do. And it's a good thing that James pointed out the title, actually, because I think something that's become very clear over the last year is that AI is really undergoing an industrialization period. I think everything in this room, every commodity, every chair, every item of clothing, is the result of some industrial process. It would be impossible to detail all of the things that have been made in this room. And really, as someone who works in the space, I don't know if you find the same thing, but it's impossible to keep up with the number of models that are coming out every day. There's new models that are released every week, there's new things that continue to come out. And it's a real frenzy of new ideas. Is everything okay with the audio? You all good? Is that better? Okay, I'll use my hand. How much of that did you get? Do you want me to start again from the beginning, or? Okay, great. So today I want to talk a little bit about how we build models industrially speaking. So how we go from an idea, something that we want to build, something we want to develop, into something that we can actually use. And to start, I really want to begin with this very traditional way of building models. So this is what I would call the artisanal way of building models. You start with some data set, perhaps you got it from the internet, perhaps you got it from your friend down the pub, it's kind of irrelevant. Then you choose some architecture, and choosing here is in air quotes because normally it's just based on your vibes, right? You think to yourself, oh, this is a reasonable way of doing this, but you don't have any way of knowing. You then just train the model, and by the way, the word just there does a huge amount of heavy lifting, right? Anyone who's actually trained a model will tell you that this block in the middle here can take months and years to actually get right. And then once you've got some model that you've trained, it's got some knowledge of the world, you do this thing at the end called fine-tuning, where you take it and you teach it to do some particular task. I think every model that we've seen so far at this conference, I might be wrong, has been a fine-tuned variant of some existing model in the world. So it's been some model that has been pre-trained somewhere, and people have come along and done some like LoRa adaptation or things like that. So this is the very traditional way of training a model. But the thing is that this is just one out of the universe of models that we could have trained. If you take any of these pieces and you change them even a little bit, the model that you get will be very different. It will have different properties. In fact, those of you who are into sort of bespoke clothing or things like that will know that every piece is individual because it's tailored for you. That doesn't mean that it's good, it just means that it's tailored for a particular task. And one of the things that you really lack here is any ability to get insights into what's actually going on, right? We just know that we have trained a model, but we don't know whether we've trained a decent model. So if we were to try and make this process, say, more reproducible, the first thing we would do is we would add a way to evaluate the model that we've trained, both during training and at the end of training. Now, I want to be clear, this is not a silver bullet. You will get people all the time who will talk to you about how evaluations are really all you need. But actually, I think anyone who's used a frontier model will tell you that that is not true. The important thing behind a model most of the time is how it feels when you interact with them, right? How they converse with you, the nuances of what they do and don't know. It's very hard to actually capture that in an automated way. And so I want to be clear here, I'm not saying that this is some silver bullet. Instead, what I want to point out is that this is kind of like the standardized testing that you undergo at school, right? It's to make sure that the model is reaching some developmental milestones as you're training it, so that you can intervene if you need to, or you can adapt if you need to, right? This is not some overarching thing of, oh yeah, this model is amazing. It's just to make sure that as you're training the model, it's doing things that are reasonable. Of course, to run evaluations, you need to actually be able to run the model. And so the next piece that you need when you're building a model in some sort of reproducible or industrial way is you need a way to run inference. And you need this remarkably early. In fact, we tend to run, I think we start running our evaluations a few thousand steps into training, so you can't delay this process. You need it remarkably early. And one of the things about this that's really important is that you obviously need to offload the weights of your model as you're doing the training. But you don't want to slow your training down. You don't want to stop your training because it's incredibly expensive. It's incredibly difficult to do this. So you also need to build some way of quickly transferring weights from your training to your inference. And by the way, it's only a single line, but this is one of the hardest things to get right. Because actually, more often than not, these two things are entirely independent. You don't want this inference service to always be running. You only want it to run when you're running evaluations or when you're doing something else. Whereas by contrast, your training is presumably running all of the time. And equally, you want the ability to scale these two things up and down independently, right? You want the ability to scale the number of nodes that you're using for training, yes. And you also want the ability to scale the number of nodes that you're using for inference. And you don't want them to be tied together. So even at this stage, we've already got a huge amount of complexity going on. Something that, so I mentioned earlier, we train models for code execution, right? That is our main thing. We want to help people to write better software. Once you have this bit at the top, so you have all of this infrastructure around evaluating your models and stuff like that, you can do this stuff at the bottom. So you can add things in that will actually make your model better at particular tasks. So just to give you an example here, I think one of the things that really morally bothers me about LLMs is that to get them to be good at things, you need to show them the entirety of what humanity has essentially produced in that field. And it's nonsensical, right? On its face, it's a farce. Because if you had to read every single C++ program that ever been written to learn how to write C++, you would never get started. It's nonsense. Instead, the way that humans learn things is by doing them, right? It's by actually sitting down, it's writing code, it's getting compiler errors, it's learning from that experience of doing. And so one of the things that we do during training is we allow a model to execute code. There's a whole load of things that goes into this, right? You have to take your repositories and containerize them, you have to define tasks properly, you have to define some clear success and failure metrics. So this is not necessarily a straightforward thing to do. But when you have it, your models get way better than they were before. And actually what's really interesting about this is that you can place this at any point during your training. If you want to, you can just do it during pre-training when the model is already learning from next tokens, or you can do it right at the end when you're doing fine-tuning, or a mixture of any of them. You always have those options. You always have the ability to take these pieces and just put them in slightly different places. I think something that should be obvious, one more thing that's very important before we get on to the next point is I mentioned earlier that we had just picked some architecture in some way. But this is not really how science works, right? If you wrote a paper and you said, I'm just going to randomly choose something, and you had no explanation as to why other than the vibes seemed good, that's not how you do anything in a rigorous way. And so there's this very popular thing in the industry at the moment called ablations, where you take some architecture or you take some choice, you train a small model in some way, and you see, okay, which one is better? Which one works better on this data that I have? Which one works better in this setting? The thing is that coordinating all of that by hand is really, really tough. There's a lot of stuff that you just need to do to even get off the ground, right? If you had to sit and babysit all of your training runs that were going on in parallel, it would require a much larger team and a team of people who, quite frankly, are doing work that isn't that interesting or important. So what we did was we built this thing called our model ablation platform that lets you, when you're training a model, say, hey, I want to vary these parameters. Please go off and do all of the work for me. And this, I have to say, from all of the things that I'm going to talk about today, has been the most transformative thing about how we work internally. If I have an idea that I want to try, I implement it, I start it on a weekend, and by the time I come back on Monday, it's all done and I can look at it. Or overnight, or over lunch, whatever it is, you just define what it is that you want to do in a for loop, essentially, and then right at the end, voila, you can see which one is better, what worked, what didn't, all of this. And it makes having confidence in the models that you actually build really easy, right? Suddenly you have a much better way of understanding, okay, of my solution space, of all the models I could train, this one is going to be good. And it just makes your life so much easier. As I've kind of already mentioned, there's a lot of pieces that are in movement here. And I really want to emphasize this point because I think as an industry, we really suck about talking about what actually goes behind model building. A great deal of modern model building is essentially systems work. And I want to be clear what I mean by that, because it's an overloaded term. On the one hand, you have to coordinate all of these pieces, right? If you look at this slide, just scheduling all of these jobs, making sure that they all run when they're supposed to, making sure that nodes don't fall over, making sure that all of the infrastructure works, is already a huge engineering challenge. On the flip side, there's also a lot of low-level optimization work that goes into making all of this run efficiently. So recently, Poolside announced that sometime next year, we're going to have something like 50,000 GPUs. A 1% saving there is 500 GPUs, which is a huge unit of work, right? You can actually do useful and interesting things with that number of GPUs. And so even just doing like the traditional systems programming of taking some kernel and making it 1% faster actually has a real and beneficial economic impact on your company. Although a lot of it is systems work, I want to make it very abundantly clear, the rest of it is science, right? It's this process of having a hypothesis, testing a hypothesis, smoothing out all of the variables, recording what it is that you've done, and making sure that you can repeat your experiments in a way that actually makes sense. One of the problems that we had very early on was that you would do a training run once and it would give you a model, and then you would do it again and it would give you a model that was ever so slightly different. And it makes your life just completely infuriating because, was it because I introduced a bug? Was it because training is non-deterministic? Was it because I woke up on the wrong side of bed, right? You have no idea what that difference is. And so building a way to enable you to actually do this sort of science, this real rigorous experimentation, makes your life so much better. It's really how you have to work if you want to produce models at scale. One of the things that really contributes to that in a big way is your data. Now, this diagram is deliberately simplified, but this box here does so much heavy lifting, it's not even funny. I've put it down as filtering and lineage, but in practice, you could have any number of about 30 different steps, various mixes, parameterizations, different data sources, things you're going to include, things you're going to exclude, different thresholds for different parameter sets. It's a real pain to do this. And if you were to do it by hand, you would go insane. You would make a mistake. You would leave something out. You really need to lean on the power of automation here to actually get this to work. So inside our model factory, what we have is a way of essentially uniquely identifying each data set and the transformations that were applied to it, and the ability to replay those filtering steps and tweaks that we made to each data set on demand. You just go in, you click a button, and it does it all over again. It rematerializes all of your changes. And actually, something we'll see later on is you have a huge top-down view of all of the data sets that went into a particular model at any given point. You can recreate all of them. You can go from the beginning if you want to. Everything is just completely deterministic. And it just makes your life so much better. You don't have to worry about so many of the low-hanging fruits or the little specks or details that would otherwise trip you up. Now, in some things, these details are desirable. Right? I've already spoken about clothing. In clothing, the individual maker's marks or those details is really desirable. But in large-scale manufacturing, you don't want that. You want to have this process where everything is going to be exactly as you expect it to be. And having this filtering and lineage really helps with that. Now, of course, there's more to this. One of the secrets of modern AI is that we all use the internet, right? Everyone takes all the data on the internet and trains on it. That's not a surprise. The thing that we're less good at talking about is that actually we spend a great deal of compute as an industry on rephrasing data, on taking data and putting it into new formats that are actually more suitable for our model. So one of the big things over the last year, for example, has been agentic workflows and conversations. There are actually ways that you can phrase your data early, so like way before you do pre-training, that actually give you better agentic models at the end. And so you can use a great deal of compute to actually take this and to rewrite your data in a way that is better for your model. And equally, of course, you can just generate data synthetically, right? You can query some model, you can get some response. Perhaps you've got some data that you really want to train on that's underrepresented. Well, you can use synthetic data generation for that. And of course, that also relies on inference, right? That relies on the ability to query a model, to ask a model questions, to have a conversation, basically, and to get some answer out. And something I really want to point about this here is that you can see all of these boxes are beginning to talk to each other in quite a big way. In reality, I would say that every box on this diagram talks to every other box. It's a fully connected graph. None of these really sit where they sit for the sake of this conversation. But the point about this is that the power of your good abstractions can't be understated in this world. Good abstractions compound, especially when you're building models. And in this context in particular, once you have these pieces, there's so much more that you can do. By the way, another box that's here that I really want to emphasize is in a traditional way of doing model training, you decide on your data set ahead of time. You pre-install it manually on the nodes that you're going to use for training, and then that's it. It turns out that this is actually kind of a dumb thing to do for a couple of reasons. So one, it means that you've got to predetermine your data mix ahead of time, which is already kind of difficult in some senses. The second thing is you have to know which nodes you're going to train on, which again is actually a real pain, right? GPUs aren't actually that reliable. Sometimes you've got some other pressing compute need in the company. You need to scale things up and down. It's not easy to just decide ahead of time what it is you're going to do. And the last point that I really want to point out is that sometimes your data is so expensive to actually generate that you want to start training before you finish generating it. So annotations are a good example. Anything where you have a model that's somehow judging the quality of your data, you want to be able to start doing all of this stuff before this stuff on the left is even finished. And it turns out that one really nice way to do this is actually to build something that enables you to stream your data to the nodes that are doing training. Now, again, this is only a small box, and I want to make it clear this is not trivial, right? This is a very difficult thing to get right. But when you get it right, it enables you to do so many great things, right? Suddenly you can play with your data mixes on the fly. Suddenly experimentation becomes very easy because you can say, hey, I did this training run with this, 50% of this data set and 50% of this data set. What happens if I do 70-30? What happens if I add another one in? What happens if I tweak how I do learning rates for different things? You can do all of these things just by decoupling your previous assumptions that you had about how training should work. Of course, I mentioned earlier, it's right behind me. I mentioned earlier that evals are not everything, right? You want to be able to do some sort of manual checking of things. And so we have this platform internally that lets you just test a model. Right? You take a model, it's automatically deployed, all of this stuff works, and you can just interact with it. And by the way, I know the way that we normally talk about this industrially is, you just do chat or something, right? You just do an agentic query or whatever. It turns out that this step at the end is really useful for doing very small sample inspection. So to give you an example, let's imagine that you have a model that is really, really good at JavaScript, but for some reason sucks at TypeScript. I can't imagine there's many models that do that, but if you were to find one, it can be very useful to look at what the model does on a particular sample. So you just drop a TypeScript sample somewhere, and you see what the output is. And it sounds crazy, but if you just look at the data, after a while you get a good insight of, oh, actually, this fundamental thing is what my model struggles with. This is where it's getting muddled up. This is where it's getting confused. How can I write an eval for that? How can I make sure that when I train a model next time, that this is properly reflected in my data set, and so on. And it really makes having a sort of a good idea of where your model sucks much easier. It makes it much easier for you to look at it and go, okay, this is where I'm going to make things better next time. Of course, I've already kind of hinted at this, but you don't just want to do these ablations on just your architecture, right? You want to adjust all the things. You want to change all the things. You want to be able to play with your data mixes. You want to be able to play with how the data is blended, all of these things. Again, this diagram is not as representative as it should be. Really, arrows should come from here to all of the boxes on this diagram, perhaps with the exception of valuations, because you want to be able to play with everything. You want to be able to adjust every knob that you can to get a model that is as good as it can possibly be. And by the way, something that really should be from here is we've started doing a thing where we will, before we train a model, we will just see, hey, what is its inference characteristics like? When we actually deploy this, outside of it, just being a small model or whatever, what does it look like to run this model in production on certain workloads? And actually, when your models are roughly the same, when they perform roughly similarly, this is precisely how you should decide what it is that you're going to do. Right? You should look at how it's actually going to be when you deploy it in practice and what the performance characteristics of that look like. I want to really end on this point, which is all of the boxes in the previous diagram were kind of arbitrary. There's a reason why they're there, yes, and I hope I've done a good job of explaining them. But there are other boxes that we have that could go on that slide. And one of the great things about having a factory, one of the great things about having an automated way of deploying all of these pieces is that suddenly you start looking for things to add to it. So to give you an example, one of the things that wasn't on the previous slide was quantization. Right? You have a model, let's say it's in bflow 16, but you really want to adjust it down to int4 or FP8 or whatever it is. Now, one way to do this is just, at the end of training, I'm just going to manually quantize my checkpoint. Great. But actually, shouldn't we evaluate that earlier? Shouldn't we look at how our models perform post-quantization if we're going to quantize them? Shouldn't we see how that impacts how we do on certain evals, how the performance is, how just various different qualities? And the answer is yes, right? We should do this earlier. And so when you have a factory like this, when you have all of this orchestration, all of this way of actually running things, suddenly you start looking for more things to add to it. And it kind of builds on top of itself. It kind of helps you to get better at building models by virtue of the fact that it exists. As a follow-up point to that, so one of the things that I really glossed over earlier was we have this thing down here. We have code execution platforms. And what this is it's our way of, we take some repository, we containerize it, we make it so that models can interact with it. Now, that process, it turns out, is actually really tough to do statically. It's really tough to do that from some predefined set of rules. With Python, it's probably quite easy, right? You just type pip install and life is good. But if you've got a C++ project, that's really tough. And one of the really frustrating things for me personally was that humans are really good at this. Right, we know, oh, I'm just going to look at the README, I'm just going to follow the instructions, I'm going to type make install, and life is good. But it's much harder to statically teach a machine to do that. But something we really noticed early on was that actually models are really good at this. If you have an agent, it becomes very, very easy to do this. And so what we did was we built a model that could build containers, And then we use those containers that were built to improve subsequent iterations of our model, right? Because suddenly they have a much wider variety of tasks that they can do when they're training. And you can see how all of this really feeds into itself after a while, right? We can, if we get a good model, we can make better synthetic data, which means we can make better models next time. We get better at evaluating, we get better at annotating. All of these things get better by the virtue of having all of these pieces in place. Now, this has been a really brief summary of everything here. I know I've whizzed through a lot. We have something like 35,000 words of write-up on this on our blog. If you're more interested in any of the details, of course, please feel free to come up to me. But I also recommend that you go and read those if you're interested, because it has way more of the details and rationale behind all of the stuff here that I otherwise wasn't able to get into. And lastly, in closing, I want to talk a little bit about myself. So Poolside really was my first exposure into AI. I didn't come from this. And in a lot of ways, I feel like I have gone from an artisan to an industrial worker. I have gone from making things that were very small, that were very detailed and beautiful, to making something that matters at scale. And if that journey resonates with you, if that's something that you're interested in, then we're hiring. Please come and talk to me afterwards. I would love to hear from you. And with that, oh, there's one more thing I forgot. This is what this looks like in practice, just to be abundantly clear. So I mentioned earlier about filtering. I mentioned earlier about how you take your data sets and you go through them. This is an artist rendition of what that actually looks like. So when you have your data set, when you take it and you go through all of these different steps, this is what it looks like in practice. This, I have to point out, is, like I said, an artist rendition, right? This is not how it actually looks. But this is the main idea. You can see everything in an acyclic graph, and life is all good. And with that, I'd like to end. Thank you all for listening. Happy to take any questions.
One thing that really struck me there was how clean those diagrams looked and how fucking messy it must be under the covers. So, that's my first F-bomb of the conference. I've been very well behaved. Oh, it's not my first? Oh yeah, I've been very well behaved, but one had to come out at some point. Yeah, so any questions? Over there, Tom.
Thanks for that. This is a super naive question, not something I've come across before, but I thought it was fascinating. Model ablation. What's the state of the art today? Is that like a manual observational process, or is there like, can you have a self-pruning LLM? Is there a role for evolutionary reinforcement learning in that process?
So that's a very deep question. So I'll tell you roughly what my understanding of it is, and then maybe offline we can talk more about it. The way that you normally do it is you take your model architecture. So let's say you know that you want to have 70 layers or something like that, and each layer is going to be of a certain width. You scale those things down, you train that model, and then you use scaling laws to predict what it would be if you were to scale it up. So that's normally how you do it. For reinforcement learning and things like that, it's way more complicated. I've just given you a description of what it is for typical LLMs. We can talk about that offline.
Any other, Fred again? You're perky this morning.
I know, I'm feeling it. Thanks, Joe. So people that I know in the industry are really starting to mention that creating these RL environments is the key piece of the puzzle. Mm-hmm. How have you guys fixed that issue? Do you think it's a data issue? And how do you actually solve? So let me actually step back and give you an aside. So you mentioned the C++ example, mm-hmm. right? That is a pretty great example. We're certainly seeing a lot of companies put a ton of effort into building these RL environments for code specifically. I don't know if you have perspective on this, but if you do, how are you thinking about these RL environments? How do you source them? And how do you pick and choose what verticals to focus on? Obviously, code is a...
That's a question with a long answer, so I'll give you the clip notes. Actually, if you go on our website, there's a research vision that we posted something like nearly 2.5 years ago, I think on day one of the company, where we say that the next scaling axis for LLMs is going to be reinforcement learning. I like to say we've been doing reinforcement learning since before it was cool, but I've been told off for that. It's before it was popular again, because apparently reinforcement learning has always been cool. The answer to the question about verticals is we're very customer driven. So if we go to a customer and they say, we really want, I don't know, let's say good COBOL performance, then we put extra effort into making sure that we expose our model to COBOL tasks. One of the things, I wish I could show the diagram again, one of the things about the introspection platform that's really useful is our solutions engineers will go to customers, so this bit here, our solutions engineers will go to customers, they will talk with them about what isn't working, they might in some cases get some samples, and then our engineers will take a look and go, okay, yeah, we can see why. So really, we're very customer driven by what it is that they want. I will say it's a really hard problem because there is a real mismatch between the type of code that is available in the world and the type of code that is interesting to companies. Right? If you went on GitHub right now and you looked for the number of COBOL repositories, there's probably not that many, but there's billions of lines in enterprises. So it's certainly something where I won't give away the secret sauce, but we put a lot of effort into making sure that our models learn on environments that are representative.
Okay, thank you. Okay, there's a lot in that. In fact, it's been quite an information-dense morning, which I guess is good. That's what we're here for. I think my favorite moment actually is just if we think about the interaction, it's the moment of magic, and it was the moment when we checked the Portuguese accent, and I saw a look of recognition rather than horror. And I think that was a moment of surprise, and yeah, so that very human aspect, that's a key. I'll remember the looks on your faces. Yeah, okay, so our next speaker, looking forward to this. I'm gonna not ramble on too much because we all need another coffee. So Nikita Komich from Zafon, welcome.
Yeah, thanks everyone. So I'm from Zafon. We're a research lab and we train foundation models for computer use. And then computer use is kind of underappreciated topic and it's now becoming hot. Big labs are working on this. We were kind of early on, and so I will try to kind of cover our journey here and what bottlenecks computer use. And of course, the upside is really high. People are interested in automating workflows. You know, we're always hear this talks about how you know, we're going to automate white collar work. I think this is kind of the way most players bet on this. And yeah, let's just take a look. So first of all, what I mean by automating, you know, workflows and computer use agents is just like a LLM acting like clicking for you and typing stuff for you. And so you install an app or something like this, and it somehow interacts with a computer on your behalf. Now the consensus here is I think best performing models, they all interact with computer by just, you know, it takes a screenshot and then it sends an action like click, I don't know, coordinates or like type something. It might seem like not the smartest way to do it, but it's actually not that bad compared to like the alternatives. And I think the consensus is, you know, that's how it operates. And now let's look at the you know, state of the art. What is going on? So there's not many benchmarks. There are not many good benchmarks. But I think the one that people are most looking at is OS World and related things. And again, computer users get more and more attention. You know, in latest release, Claude mentioned the first thing is OS World results. And just to get a sense of what we're dealing with, here's like a task that this is human interacting with computer, just showing the tasks. This is what model sees in a benchmark, and you know, it just has to, you know, restore some file from the trash. And that's the task we're dealing with. And here's the results of, you know, the SOTA models. And so as you can see, it's not really good. The task is really simple, and even in the best models, they kind of don't perform really well. But as I mentioned, even with simple workflows, the economic upside is really high. So yeah, that's kind of the background. And so we started with first principles. So we were like, well, how do we make a good computer use agent? We started around a year ago, and initially it seemed like relatively simple. So we're like, well, can we just like fine-tune on some successful trajectories, or like it shouldn't be that hard, we thought. So the first thing, but we tried to reason from like first principles, and the first thing we needed is some way to interact with computer, regardless of whether you want to SFT or you want to do some RL. You probably want a way to generate data at scale, and so that's kind of the first thing we did. This is yeah, that was our first idea, and so we released a waypoint. Waypoint is like a way to interact with computer. Initially started with browsers, now we support OS. It's kind of a nice solution by itself. It's fast. It maintains a warm pool of browsers, so you don't have to like. It's really fast if you want to collect data. Here's a simple script. I can show you how you interact with computer. So here you can see a this is we released our SDK. It's really nice. You can this is. You can just run it. Okay. My Wi-Fi is disconnected. Yes. I can just run it, and so that was the first kind of bottleneck that we solved. And here we just take a screenshot. We do something random, and here's a screenshot that something happened in a computer. So that was our solution to kind of the problem of generating data. And so now as we can generate data, the idea is, well, why don't we just take some tasks, generate a lot of trajectories, take successful ones, and either just SFT on them or do some kind of reinforcement learning. And it doesn't really it somewhat worked, but it didn't really scale well. There's a couple of problems here. So first of all, when you start generating trajectories, by trajectory I mean say you set some high level goal like buy me tickets, and the model would go on a website that would be the first node, then it goes further and further, and you get this sort of tree. The problem with it is it's kind of low entropy tree, so it would often just go the one trajectory. And the second problem is when we try to RL in it, because the models are they kind of don't really understand computers, so it's hard to verify. When you build automatic verification, the rewards are really sparse. If you try to just ask ChatGPT whether the model accomplishes the task based on a screenshot, it doesn't really answer well. But the one that we've been able to make the agent work is in the domains with verifiable rewards. So say terminal tasks, like when you execute tasks on terminal, or like when you have HTML and you know exactly what the solution is. Like say you ask an agent to find something in the website and you know the concrete answer, then it kind of works quite well. So our first idea was we looked at the performance of existing models, and we're like, well, it seems like they don't really notice that when they do something stupid, they don't really come back. It would be really nice if there's like just a really smart model would divide a task into like a subtasks and maybe guide the model, a smaller model, and that seemed like a more natural task for like more NLP-like. Say when you assign a tasks, it seems like a task that you can learn with RL. Back in the days, there's no previous speakers spoke about the post-training and pre-training, and there was no really good RL infrastructure back in the day, so we kind of had to implement it ourselves. It's kind of surprising that it's learned. So we took a supervisor model with Gemma, which gave instructions to a Quen, and we generated a lot of trajectories. We SFT'd on them. We did RL, and surprisingly it improved. So it was kind of a big deal because there was no infra, there was no it was quite new. But it didn't really scale. And the problem is the model, this approach doesn't really generalize. So when you train on terminal tasks, or like when you train on I don't know, browsing file system, or like something like this, it doesn't really generalize to other domains. We examined like kind of the performance and the benchmarks, and there was common failures. Like say the model would understand where it should click, but not click the right thing. And you might think, well, it just doesn't understand the coordinates. And the issue is quite deeper. If you examine, say the model, there's a general grounding problem. Say the model wants to click some button, and it doesn't really recognize which button is correct one by the description, so it click just other buttons. So if you look at the distribution of errors by coordinates, it's either 0 or like a lot. So yeah, here's kind of the picture that illustrates it. So when you ask a model like click some button, it either it either clicks here or there. So it's like the error is large, and the problem is we played with it a lot, and the problem is the model doesn't really understand grounding. It kind of what you expect, because the way transformers process images, they just like they patch image into a grid, they flatten each part of the grid, and they basically treat it as tokens. And oftentimes most of the times the open source models, the way they train multimodal is they take a text-to-text part and they try to attach a vision part after text-to-text is pre-trained. So of course, as text-to-text part is really good. When we train on, say, image capturing data set, a lot of the variance is explained just by text-to-text part, because it's so good, and the signal from images is quite bad. So we kind of felt like well, we need a fundamental solution here. So what we needed is to either throw a lot of the data in pre-training and or just fine-tune existing vision encoders on a lot of screenshot data, and we decided, well, why don't we just build a model from scratch? So we decided to pre-train a model, and the pre-training was covered quite extensively in a previous talk, but it was very much the same. So we took a data set, we filtered it, we did ablations, we did meat training, then we did RL, and so this is a standard cycle. But we still found the attaching vision encoder part is quite hard. So for now, we just took Qwen vision encoder, and because it's kind of the best of open source solutions, and we fine-tuned it on a lot of data from say tutorials where you have like a tutorial somewhere, and the person explains what is going on the screen. You would transcribe it, and we found this quite helpful, but it's still ongoing research. Yeah, this is aside. There's been a lot of infrastructure progress. Even half a year ago, the infrastructure was really poor. There's the pre-training and post-training was kind of hard. Nothing worked. Checkpointing didn't work. Now it's way better. So now there's the ones I really enjoyed, mostly Torch Titan and Torch Forge from Meta. Those works really fine, and we don't have to deal with it ourselves anymore. It's really efficient, and we even achieved 40K tokens per second per GPU. It was SOTA at the moment with some modifications made to Torch Titan. Yeah, and we played a bit with pre-training. So we did a pre-training. Large part of it is in FP8. It's kind of yeah, people don't really do that, but we managed to make it work. We also are able to make mixture of experts converge. We do a lot of pre-training stuff now. So, but yeah, to summarize, now we kind of we're a small startup, so now we mostly are focused on the real model, which we pre-trained, and I'm not going to focus too much on pre-training because this was covered in the previous talk, and Olmo, the Hugging Face model, did a great job at describing the recipe here. So what you can expect is new model release, obviously, and an app for a desktop. It's now in beta, and the agent would act on your behalf on your computer. I think it's kind of cool, but the things that you can use even now is the waypoint, and for whatever task you want, it's as long as you need to collect a lot of data, and or like you want a fleet of browsers or lightweight Linuxes. That's a great solution. And yeah, that's pretty much everything I wanted to cover.
Yeah. We're kind of running super late, so I don't think we've got any time for questions. Nikita's around, so if you want to chat to him during the break. Yeah, great sessions this morning. Lot to think about, hopefully a lot to talk about. And maybe something to have coffee about. So let's go for a coffee break. We are running late, so let's come back in at like 10:02, and we'll crack on from there, but get some coffee. And thanks everyone, and thank our speakers.
Okay, yes, I am very audible right now. Do you need me to keep talking a bit? Sibilant?
excited to introduce
Okay. Welcome back. Welcome back. So, I think in conversation last night, I actually had dinner with our next speaker, and thinking about the human aspects of technology, how we support different communities, whether we are inclusive, whether the spaces are safe, how can people moderate their own communities, subjects like that I thought were really interesting. And perhaps get to some of the issues of putting the human first and some of the themes in the next few talks. So, our next speaker is an independent. They have done a ton of interesting stuff in their time, including making the docs for React Native be awesome. I am going to get out of the way. Oh, I've never seen such amazing color coordination. That is absolutely bang on. So one of the other things our next speaker also said, they said, I put a lot of work in. And pretty clearly, that is the case. So let us have some better engineering with right-sized models, Rachel Lee Neighbors.
Thank you for that lovely introduction, James. And it's good to see you all here. I live in London, but I have American heritage, as you can tell from the accent here. I'm Rachel Lee Neighbors, and I have worked on the standards that power today's web. We have had a lot of people who work on the back end here today, but I'm more of a client-side person. I've worked with Mozilla on Firefox's DevTools. Get a little bit of feedback. The W3C on web standards and Microsoft's Edge browser, and of course, even on React. How many people here reference react.dev? Okay, good. That was my pandemic baby. It was fun working. And how many people here have a web background? I'm curious. Lovely. How many of you are machine learning background? All right, well, at least I'm kind of curious about everyone else. I'm sure there'll be a survey. Today, I'm going to help you use AI without setting the world on fire. How many of you are concerned about the environmental impacts of AI? Oh, I love how conscious you are. The rest of you are evil. So we're talking sustainable AI today. Now, every time you reach for a foundation model like GPT-5 or Claude, it's going to cost you. Monetarily, it's going to cost your users. It's going to cost the environment. How many of you are actually using these frontier models in production today? Okay, well, let's see if you have a different idea about that. So how exactly is it costing us? Let me elaborate. So security costs trust. Sending data to remote servers always carries the risks of exposure, interception, and retention by third parties. We have had cases where the use of remote AI chatbots led to sensitive business data being stored, breached, or leaked. Latency costs the user experience. Research on mitigating response delays in LLM-generated chats in VR found that a 4-second delay, as it were, had a substantial degradation on the user's experience. This is quite down from similar studies in the 1960s that found a 10-second delay was the limit of user patience. It costs your business. Third-party inference costs are, compared to the steady linear growth of API costs, rather uncontrollable, and agents eat into compounding levels of inference the more you use them. Training and inference cost the human species. Most of the cost for LLM's usage comes from the training, but the ongoing cost of using the inference has a growing impact on resources like electricity and water. Thus, as we continue to use LLMs more and more, we can expect these inference costs to begin to dwarf the training costs. In fact, that is the bet that big tech is making. And of course, if you aren't connected, it won't work. You cannot, if you do not have the internet connection with which to make a call to the large language model at a data center, you have a brick of a piece of software. So not so great for the client side. I'm not an AI doomer though. Believe it or not, I'm actually a centrist, and nobody likes the centrists because you're not committed to one cause or the other. I'm not going to hand wave about inference costs one day going down because, oh, the chips just need to be better and we have all these experiences where costs go down. I come from the free and open web, which has a local first ecology and likes to do things Spartan and efficiently. Foundation model companies, they want to sell us access to models that can do everything. They are chasing features. And that's great for them, but we're talking production here. Production is very different. Now, let's take a look at some models that are small in size and power consumption compared to a foundation model. Task-specific models do one thing really well, and they're widely available in the open source community. Here's a cheat sheet. We're not going to spend a lot of time on task-specific models because I've only got 20 minutes. But if a camera is pointing at something, you can probably use a vision model like MobileNet, YOLO, or MediaPipe. If a microphone is recording, you can use an audio model like Whisper or WAV2Vec2. And of course, chat, translation, analysis. Consider a small language model like Gemma or Qwen. Anybody here using small language models? Okay, anybody here not know what a small language model is yet? Too late, I'm gonna tell you. There are times when we do need the power of GPTs, but we probably don't need the sum total of human knowledge in a black box in our pocket. Most of the times we don't need that. Research facilities do, but the everyman trying to watch YouTube videos does not. SLMs, they contain millions to billions of parameters. It stands for smaller language models. I have a friend who's like, they're not small, they're like medium-sized. You can't call mine a small language. Smaller, dude, smaller. Smaller language models contain millions of billions of parameters. You can compare that to frontier models that they contain billions or even a trillion parameters. And they use less energy than large language models, and they can still produce correct responses. And they're so light that they can be put on devices. My phone, which I left in my chair, but I usually like to bring out at this moment, Pixel Pro, it ships with Gemma Flash on device. And this is a comparison chart here. You can think of, for every 1 billion parameters you get, it costs about 2 gigabytes in FP16. Most smaller language models for mobile and web, they're deployed with quantization, which can have recorded the disk and memory requirements. This is a grid giving you an example, which I'm standing in front of, very conveniently. Now, let's compare the power usage of these different models. So if we're going to use LLMs energy consumed for inference, this is the gold metric here. SLMs, smaller language models, can use up to about a quarter of that energy to produce the same result. Of course, this is with appropriate prompting, blah, blah, blah. Task-specific models will use less than half of that, so we're talking maybe an eighth of the same cost. That's in terms of energy consumption. We're not including water, we're not including the cost of actually paying for calling the API, which would be zero if you're hosting some of these models yourself. So the benefits of small local AI are many. They're more secure, work offline, no fees, especially if you're using an open source model, more efficient, and lower latency, because you're not round tripping to a server in God knows where, exposing your data. So how do you pick the best model for the job? I have a framework for this. Here's how you do it in 4 steps. First, you want to prove that what you're trying to accomplish is possible. This is where foundation models are super useful. Just prove that you can get it to execute a complex task with the right prompting and access to the right resources. You want to set your success criteria. What does good look like? Foundation models are actually really helpful for generating your success criteria. And then you want to test. You start with the smallest models possible, the tiniest ones, and you run them against your success criteria until you get to a size that's maintainable. And then, of course, you select the smallest one that gives you the right feedback. All right, I really tried to come up with a cool acronym for this, but the best I got was PSS. I tried, I really tried. I'm working on it. If you have an idea for an acronym for this, let me know. I want it to be stickier than PSS. You're right, it probably does mean something really cool in cat. Now, an easy way to summarize this is prototype big, deploy small. You can use a foundation model for prototyping. It does everything. You don't have to worry about, oh, which visual model do I want to use? No, use multimodal. Go for it. Those inference costs, those are research budget. But then you convert parts of it to smaller language models and specialized models for production as you can get them to meet your success criteria. Ba-boom. All right, deployment. This is actually the part I find super fun because obviously I want the future in my pocket and take it with me everywhere and available offline. The biggest thing to remember about deployment is to keep the model near your data. The less you're shipping data around, the better. The less you're exposing it, the less the latency costs. So basically, sometimes this means you want to keep everything remote. You don't want it on the user's device. Like, connectivity is a constant. You know, if they're in an office environment and they are wired in, and you have 100% uptime with that connection, of course you can use a remotely hosted model. And data, if it's on the remote server, you want to keep it near that data. For instance, say you have a securely locked down database of personally identifiable information. Yeah, you're probably going to want to put your model next to that and not on the terminal. And of course, if the usage involves complex tasks, or bandwidth is high, or the responses are small, remote is wonderful for that. And if you have security processes and procedures in place, perfect. And of course, if you have a limited electrical supply, a remote inference can cost the user less. This is actually really important for mobile devices. When I'm using the AI features on my Pixel, it does like to eat the battery, and yes, the chips will get better. The chips will get better, and the batteries will last long. Yeah, we know. But if you're in a situation like if the phone has less than 10% battery, you might just want to use an API call at that time to a small language model on a remote server, just so that your user doesn't have a brick on their hand. No bricks, no bricks. So, deploying locally when offline mode is required. Your user's got a spotty network, they're in the field, or maybe they're in a mine or a secure facility that doesn't have connectivity to the outside world. Data is on the device. We're talking user photos, text input, recordings. If the data is on the device, why are you sending it somewhere else to be processed? That's ridiculous. And the usage is high frequency. Chat, translation, real-time analysis, doing it there on the device will definitely help with those compounding latency costs. And bandwidth is low or the outputs are large. Yeah, you don't want to have to wait for a generated video for a TikTok feed that you're creating. Now, if the data needs compliance or extra security, for instance, health or finance, it's often just easier from a compliance standpoint to leave it on the device and process it there. And of course, if the electricity is reliable, such as a plugged-in desktop, or other power-tolerant use cases, which I struggle to identify right now. Maybe you know that they're plugged into a battery somewhere. And choosing the right location. Foundation models, well, they'll never be on device. You can't deliver them to the device, and they are 100% remotely. But with smaller language models, you can choose between whether you want to deliver it, use the one locally, or host it remotely. With task-specific ones, they're never going to be preloaded onto the device, at least today. So you might have to deliver them. So in short, deploy local first if the app has offline requirements or high-frequency use, sensitive data access. Choose remote first if you need a lot of complex reasoning, have large models, or infrequent use. And choose a hybrid approach, where you download small models while using APIs and switch over to the local models when ready. We already are seeing this out in the field on the web. I'll show you an example shortly. So, we know deployment, and we only have 7 minutes left. So let's focus on the 3 local strategies. You can host the model, You can use the device's model, or you can deliver the model to the device. So I'm curious, before we get too far gone, how many of you use a personal agent like Claude, ChatGPT, or Gemini? I'm not talking about, oh yeah, wow. And those of you who aren't, is it because of the money? Is it because it's too expensive? Okay, I see money is no object with this crowd. I'll assume it's something else. Well, for the rest of you, you can save some money. I'm about to show you that for most of the stuff I personally use Claude for, I can be using a local model. I don't actually have to use Claude. I do, but I don't have to. I love ichthyosaurs. This is what I go on Wikipedia and read about on a regular basis. Ichthyosaurs are ancient reptiles, not dinosaurs, marine reptiles, not related to dinosaurs, that look, for all intents and purposes, just like dolphins. And they've been dead for years. And one day I looked at them and I said, my gosh, could they have echolocation? So here's an example of, I asked Claude to tackle the question, and I asked the agent I put together with an SLM to answer the same question. And you can see them running side by side. I'll show you how to set the agent up in a minute. But essentially, Claude, I ran this many times, and out of 10 times, Claude answered incorrectly twice. And this is the second one. Claude says, oh, yeah, ichthyosaurs might have had echolocation. That is incorrect. As you can see over here, Qwen comes up with a lot more evidence. This is just the body of knowledge available to them. They're not searching the internet. They're merely working from what they've been trained on. And Qwen actually comes up with the better answer more often, which is not likely. They all have huge-ass eyes. They were designed for hunting by sight. There is no evidence of any audio equipment on this animal, and you could tell from the bones. So I was actually surprised. They're supposed to get it both kind of accurate, but Claude answered incorrectly. The important thing is that the smaller LLM here used 73% less energy to answer the same question with the same arguments. Of course, it was a bit slower to do it, but I'm also using it in an unoptimized system, whereas Claude has been optimized. So it was able to do this with no internet access, only 8 gigabytes of RAM, and running on my laptop. You can build your own in 3 easy steps. You go to ollama.com, you download it. It lets you run and build models locally on your device. Then you get yourself Qwen 3 with 4B. And then you go install Goose. Goose is, I don't know how to describe it. I'm going to call it a personal agent harness. All you do is you plug in the model that you want. You can use API calls to a foundation model, or you can use a local model running with Ollama. It uses MCP tools, it supports MCP UI, all the stuff that you would expect from ChatGPT or Claude, but you BYOLLM, or SLM in this regard. If you're curious and you want to set one up yourself and see what it's like to use it, perhaps even customize it to do what you want it to do a little bit better than the other guy, I have a video walkthrough. It's a lot of me talking, but it'll tell you what to do. All right. Option number 2. What about models that are on the device already? I mentioned that my phone, for instance, has a Gemini model on it. Well, Chrome, these days, ever since I think it's 128, ships with Gemma Flash built into the app. One day we're going to have a lot of little SLMs in all these different apps. I'm not excited about that day. But let me show you a little bit about what that could look like. Here we've got Prompt API. This is the API that the Chrome team has proposed that uses the browser's local LLM to perform inference. I was told that there would be only demos and no slides, so I'm going to show you this. Let's do it. I made a little fun thing. Here we go. So this was my 2011 Halloween costume. I'm a big Halloween fan. And I wanted to create some, what? No, why? What did it, oh wait, mirror. Hang on, it says it's mirrored. Extending, change, extended, it is supposed to be, sorry.
Yeah, there you
go. Okay, well, we're good. Thank you for your patience, folks. We'll keep going. We'll figure it out. So, the idea was, don't you hate it when you're a 2011 Tumblr girly and you're posting pictures and you got the haters coming in and saying, like, you suck. definitely a 2. And you're like, God, man. And then you get into Twitter fights. This is my history. So I thought, wouldn't it be great if we had a way to make people pause in their client and say, yo, what you said wasn't very nice. Maybe you could phrase it differently. So let me blow that up a bit. If I submit this comment, device is not eligible. Oh, that's because we're in Comet. This only works in Chrome. All right, there we go. Okay, so it's available. Model may download on first use. I thank you. You suck. And submit the comment. Analyzing, as you can see, it's not the most fast experience ever, but it is local, and it does work when I'm not connected to the internet. And it says, oh, maybe you should reconsider. The comment, you suck, is a direct personal attack and constitutes hostile and aggressive tone. I definitely need to work on the prompt. This could be a lot shorter. Anyway, try this instead. It's like, I don't quite agree with that perspective. I see it differently. Okay, definitely need to work on the prompt, but check it out. Okay. No, this is all live. I put this together. Okay, and I was like, it's flirtatious comments are okay. I want to be able to say someone's cute. Let's see. Let's see, if comment's problematic, provide a constructive alternative, maintains core message, but presents it objectively and responsively. Keep in mind, these are comments about appearances on photos, not about philosophical disagreements. There you go. All right, let's see if that fixes it. We'll find out. Remember, like, the prompt, it's all in the prompting. All right. You look terrible. All right. This is a lot of fun. I've had so much fun saying different things to it. Direct personal attack. Instead of focusing on appearance, consider the lighting in this photo isn't very flattering. Or this photo isn't quite capturing your best side. Okay, let's find out. There you go. Yay! It allowed me. All right, so this is just one of the fun new features that you can add on the client side. Brilliant. Okay, back into it. It works, but it's also mirroring, and that's not what I wanted. Hang on, change, extend. We can do this. Extend to display. Okay, moving on. Anyway, if this excites you, you can get your early access to this API at this handy-dandy URL, which I'm totally blocking, but I'll put a link. Just go to my socials, there'll be links. All right, so the future, what can we expect? As specialized chips are becoming more commonplace on devices, onboard AI models are pretty much standard in flagship smartphones from Samsung, Apple, and Google. And they're becoming more common in operating systems like more recent Windows machines and, of course, in Macs. You can access Gemma from within Chrome, and you can use Apple Intelligence in Apple-type projects. They have their own prompt API that you can go read about and their dev tools, etc. NVIDIA called SLMs, or smaller language models, the future of agentic AI because they're on device, they're small, they're pretty good at making knee-jerk decisions, as you saw when Gemma was telling Qwen what to do earlier. I've worked with both of them, and I totally expect Gemma to be kind of like that with Qwen. I totally see it. They have that dynamic. So increasingly, AI tasks, they can be completed at the edge. We do not need to keep round tripping with foundation models. We have all the things that we need. So get moving. Choose local, small AI when you're working on projects. Take a look at smaller language models and specialized models. They're more efficient, and they can meet their users where they are. Remember to prototype big and deploy small using foundation models. Think prove it, define it, test it, and select the smallest. And generally, keep your data where your model is, or vice versa. In this way, we don't have to set the world on fire to use AI. We just have to think a little smaller. All right, you can find my socials, and I'll post those links to all these fun resources. If you want to talk about how the web and AI interface together, or small language models in general, hit me up. I'm around the rest of the day.
Do you want to do some Q&A?
Didn't I hit
You
my
don't have
time
to. You
limit?
did a very good, people want some Q&A, I think. Yes, let's ask a question over there. Not over there, over here.
Okay. I didn't realize we were going for the bonus round.
I mean, you were pretty good, so we better just keep you up here for a bit.
Okay.
I can keep it tight. Rachel Lee, thanks. That was a great presentation. Appreciate it. And I like the slide toward the end where you gave a comparison, a breakdown of the relative energy use for whether you go foundational versus local versus SLM. Is the differential in cost for equal amount of operational use effectively a similar dying off chart when you go down, or is it less disparate?
There aren't enough case studies published yet for me to be able to definitively answer that. I'm trying to encourage more people to share when they're using small language models and task-specific models. Right now in the circles I run in, most everyone is using a foundation model, so we don't really have comparisons that we can use from production yet. I would love it if anyone here has a comparison that they can share of real-world use. Not just what we're seeing from papers and hypotheticals in labs. I would really love to hear that story. It could be very useful to share in some things that I might be writing for some awesome publication spots.
Hi, really great talk. Can't wait to try Goose. Hadn't heard about that, looks really cool. I had a question about the OpenAI Azure endpoint, which is kind of like in between. It's like this model that's hosted in OpenAI. It runs in Azure, but it runs the OpenAI sort of model, but apparently it doesn't go to OpenAI. I was wondering how you think about that in terms of privacy threshold, and then also like any alternatives where you can run a scalable sort of model serving platform in your cloud without doing a bunch of work, because it's kind of hard to run.
So they're asking about, hey, what about those foundation models that are being hosted by people we know and trust, like Microsoft? Aren't they pretty reliable when it comes to not leaking data, et cetera? Yes and no. Yes, they have a great track record with existing technologies, but it is a new technology. We're still learning things. Some of these issues have happened at hosted centers. So I think it's still a proceed with caution. If you do need to use an incredibly large foundation model, you aren't going to be able to build your own data center and host it in most cases. You're still going to have to rely on an external provider. I would probably lean more on people like Microsoft that have a historical record of compliance, simply because their people are the most experienced with making sure that those problems don't happen. So I would probably trust the Azure endpoint a bit more than I would trust, for instance, OpenAI's. But that's me, and I'm just going off what I know from Microsoft's track record.
Well, this is the new era where Microsoft are the good guys. I'm old enough to remember when that was not the case. Okay. Thank you so much, Rachel Lee.
It's a pleasure.
Yeah, confidence is an amazing thing. Confidence and capability, and yeah, just Rachel Lee had no doubts whatsoever that they were going to crush it today. They told me they were going to crush it, and then they went and they crushed it. So a big round of applause for that talk. Okay, and I mean the thing about that talk that I thought was super interesting is that, as I say, I have not curated this. I am merely a vessel on stage for introducing speakers. And so I was kind of like, it says it's ethics and sustainability, and I don't know how much there's going to be about that. But then Rachel Lee went, and we definitely heard some of that. Put the humans first. I thought the stuff on local models for moderation, that's just super interesting, and something that hopefully we would think about in terms of the kinds of user experiences. Build. Right. I should stop rambling. The screen is here. The next speaker is here, Clara Maltos from Sword Health, and I'm super interested to hear lessons from building the evals in healthcare at scale. So over to you.
Hi everyone, my name is Clara and I work at Sword Health, and today I'm going to talk about lessons learned from building with evals in healthcare at scale. So, when developed and deployed effectively, large language models have the potential to increase access and quality of care. However, we need to guarantee that models remain safe, reliable and useful, both before and after they reach patients. A way to achieve this is through both offline and online evaluations. So you might wonder, why is evaluation in healthcare hard? So models need to communicate naturally with patients, they need to respect clinical boundaries, and they need to fit within clinicians' workflows. So we need evaluations that capture the complexity of care with messy inputs and long-term outcomes. So in this talk, I'm going to cover how we apply an eval-driven development to Phoenix, our AI care specialist, by first giving an overview about Phoenix, then covering why are evals important, and then touching on both offline and online evaluations. So evaluations that are performed before and after release. So Phoenix is our AI care specialist that is designed to bring clinical expertise into every interaction. It supports patients both during and between sessions. So during sessions, Phoenix acts as a true companion. It greets the patient, sets expectations, and follows up on previous progress. As exercises unfold, Phoenix answers questions, responds to voice comments, and provides feedback based on motion tracking data. The outcome is a smooth and true one-on-one experience. So between sessions, Phoenix continues to play an active role by augmenting clinicians, allowing care to scale without compromising quality. Among other things, Phoenix is able to make recommendations to clinicians, detect signs of disengagement, and prompt clinicians to reach out to members at the right time. So everything that Phoenix says, when it says, and what it says is validated both before and after release with offline and online evaluations. So first, why are evals important? So the lack of evaluations has been a key challenge in deploying large language models to production. So testing large language models, as we all know, is hard and often slows down development velocity. So we need to measure the performance of these models in real scenarios to increase confidence as they are deployed at scale and in high-stakes situations. So which are the main benefits of evaluations? So first, iterative improvement. Is my V2 better than my V1? Also, quality assurance before and after release. So, has my latest model introduced any regression? Also, objective model comparison. Can I switch to another model and maintain or even improve my current performance? And finally, potential cost savings. So, can I switch to a smaller model and maintain or even improve my current performance? So, this is the process that we follow and the one that I'm going to touch on in the next slides. So I'm first going to start by speaking about offline evaluations, those that are performed before release, and then online evaluations, those that are performed after release. So first, offline evaluations. So when developing with large language models, we follow this iterative process. So we first start by building the evaluation data set, by collecting examples, defining the evaluation criteria, and performing human annotation. Then we develop a suite of evaluators, which can be code, human, or LLM as just base. And finally, before release, we perform a round of byte check to make sure that our release meets the standards in quality and consistency, and at the same time that new issues that are not yet covered by the evaluations appear. If all checks pass, we release the new and hopefully improved version to production. So, starting to speak about how to build evaluation data sets. So when real data is available, a common first step is to collect examples at random. However, this usually results in data sets that are overrepresented with simple and common use cases. In order to avoid this, we try to create evaluation data sets by gathering different types of examples. So challenging examples, rare examples, examples that stress test different parts of the application, such as tool calling, RAG, or different prompt branches, and also examples that are representative of issues that have been previously solved. For new features, when no real data is available, this evaluation data set can also be built using synthetic examples. Even when synthetic examples are even when real data is available, synthetic examples can be used to create examples that are long tail or that are rare and that haven't yet appeared in production. So this is an example of an item of an evaluation data set that we use to evaluate Phoenix conversations. So we include the same context that is passed to the model, as well as the conversation transcript between Phoenix and the patient. Over time, this data set is continuously improved with new examples collected either through user feedback or manual audits. Then, we collect our examples. The next step is to define the evaluation criteria. So for each feature, we define a set of criteria that define what success looks like. We always try to keep outputs binary, so something like yes or no, pass or fail, to reduce ambiguity and improve alignment. So this is an example. This is an example of criteria that we use to make sure that Phoenix remains with an appropriate tone during conversations. So, as we know, the success of evaluation depends on making sure that these evaluators are aligned with expert judgment. So, in order to guarantee that, we perform human annotation on the collected examples. So, we can use a single annotator or multiple annotators. In our case, usually the clinical expert or a product manager. And then for each example of the evaluation data set, this annotator will provide feedback using the evaluation criteria that were previously defined. So, once we collect the examples, define the criteria, and perform human annotation, we have our final evaluation data set. So, the evaluation data set is built. So what comes next? We need to build the evaluators. So we can build either human, code, or LLM as judge evals. And each one of these grading approaches is suited for different tasks with different failure modes. So we usually use human evaluations to evaluate things that require complex reasoning and tone. So this method, although being time-consuming and expensive and can suffer from inter-annotator disagreement, is essential to evaluate things that require expert judgment and or product taste. So before major updates or releases, we perform pairwise comparison in Gondola, our internal annotation tool, where we ask human evaluators, experts, to evaluate the model's output based on their scores. We make deployment decisions. So if a model is ready or not to go to production. Then we use code-based evaluators to evaluate things that have clear and objective criteria. Their key advantage is scalability. Created once can be used to run thousands of evaluators quickly and consistently. So this is an example of a code evaluator that we use. This is a rather simple one, and that is used to make sure that the output of the model remains within a specific number of characters. So then moving on to LLM as judge evaluators. So they are a bit of a middle ground between code-based and human-based evaluators. So we so on one side, they are able to evaluate things that are more complex and subjective than code-based evaluators. And on the other side, they are able to process thousands of evaluators in a short amount of time. So the key thing here with LLM as judge evaluators is to create the LLM as judge prompt. So this is an example of the prompt that we use to evaluate Phoenix conversations. So if I was not standing in front of it, you were able to see that we define the task, we include the transcript, include also the rubric item, which are the evaluation criteria that I talked about earlier, and then the instructions for the evaluation. So in order to guarantee that this evaluation is aligned with human judgment, we divide the evaluation data set into 3 sets: the training set, development set, and the test set. The training set is used for few-shot examples. The development set is used to iterate on the prompt and measure human alignment. And then the test set is kept untouched until the end. And it is used to have a measure of performance. So this is the process that we follow. We start simple by defining the prompt with clear structure and clear criteria. Then we evaluate the examples of the development set using the created evaluators, and then we measure things such as true positive rate or true negative rate. And then we analyze the mistakes, so the examples where the human and the model disagree. Then we refine the evaluation prompt in order to reduce the number of mistakes. And we repeat the entire process a few number of times until we are satisfied with the level of agreement. Once the desired level of agreement is reached, we evaluate performance on the test set. So once the evaluation is created, once the evaluation suite is created, it can be used to measure and compare the performance of different versions based on the created criteria. And they give us confidence about what has improved or not on the new version. So, however, although we can spend a lot of time in building evaluators, something that we cannot escape from is vibe checking. So, before releasing the model to production, we always, or most of the times, perform a vibe check round, which is basically a manual inspection of outputs. The goal is to ensure that no unexpected issues, not yet covered by the evaluators, surface. If all checks pass, we release the new and hopefully improved version to production. However, although evaluations allow us to track performance on different criteria, they sometimes fail to get the full picture of quality. So a new version can sometimes improve the evaluation metrics, but fail the vibe check. In that case, we hold the release and perform another improvement cycle. So, to perform vibe check, we can use annotation tools such as Gondola that I described earlier, or Argila, which is the one shown here. So, using these tools, the reviewers can have the full context and provide feedback in a structured way. So, this is the entire process used for development. Once again. So, moving on to online evaluations. So, once released to production, the model continues under evaluation. So continuous evaluation ensures that the model performance holds up in real-world conditions, that regressions are caught earlier, and that user experience keeps improving with every iteration. So we keep a tight feedback loop between production and development by enforcing guardrails, conducting A/B tests, performing manual audit on production traces, and running evaluators on production traces as well. The insights collected through this process are then fed back to the evaluation data set, the criteria, and used to make sure that they continue to be reliable and aligned with real-world conditions. So, regarding guardrails, some evaluators can be used as guardrails, and they act as real-time safety checks that prevent unwanted content from reaching the end user. So, typically they can be implemented as code-based evals, such as the eval shown here for latency considerations. However, for more critical validations, like for example, detecting medical advice, we can also rely on LLM as judge. So when the guardrails fail, you can either fall back to a static message or retry the generation a few times. Nevertheless, the ultimate test of the new release is conducted in production through an A/B test. So this validates if the new version derives the user behaviors and outcomes that we aim for. So in practice, performing A/B tests with large language models is not very different from performing A/B tests with common products. We need to define success metrics, which can be user feedback metrics, or usage metrics, or acceptance metrics, and then we measure the lift between the two model versions. However, performing A/B tests with large language models suffers from the same problems than usual A/B tests. So first, you need to convince stakeholders to hold on releasing a new version, and hopefully better, to the large population. Sometimes your volume of data is not enough to make decisions, right? No one wants to wait 2 months to have the results of an A/B test. And also, you need to make sure that the test is statistically sound, so you don't take false conclusions. Nevertheless, even if everything I just spoke checks out, you still need to, or most of the times what happens is that the new version is not different from the previous version. So we set up guardrails, conduct A/B tests, and continue to monitor in production. How? Through manual inspection. So as we know, manual inspection, although a bit tiresome, is one of the highest return on investment tasks in machine learning. So by regularly reviewing production traces, we are able to detect failure patterns early, understand their root causes, mitigate the issues, and create evaluations that prevent them from resurfacing. However, to make this effective, we need, you guessed it, extensive observability. So for each request or a sample, you need to, or we usually log everything from inputs, metadata, outputs, documents retrieved through RAG, different tool invocations, user feedback, and evaluations when they exist. So this visibility allows us to have a full picture of what happens in production, debug faster, and solve issues more efficiently. Finally, so once observability is in place, the same evaluators that were created and that are used to evaluate offline can also be used to evaluate production traces. So depending on the criticality of the issue, these evaluators can be used to evaluate all production traces or just a subsample. So in the case of Phoenix, which has unsupervised conversations with patients, the same set of evaluators that runs in production, that runs in development, also runs in production. So if pass rates drop below a specific threshold, the team is prompt to investigate and take corrective measure. So this is, once again, the entire process that we follow. So making large language models safe, reliable, and useful, especially in healthcare, means building trustworthy systems that improve with every interaction. So evaluations must be a continuous process and not a one-time thing. We need to define success early, create data sets, build suites of evaluators, and continue to run these checks in production with guardrails, A/B tests, and observability. So as large language models grow more capable, the bar for safe reliability and helpfulness must increase as well. So the features that endure are not the ones that move fastest, but the ones that can improve with every a new interaction. Thank you.
Thank you. I think I got too excited before, and now we are running behind because there were too many questions before, but Clara's going to be around.
Yes.
If you have any questions, I think that was super fascinating. I talk about progressive delivery, and A/B testing is a big part of that. Where do we go next in the AI side? So that was an amazing case study. Thank you for that.
Thank you.
So, thank you. Okay, and then if we're thinking, I guess we've sort of the security implications of using these AI-generated systems is a big question. We worry perhaps we're going to open up security threats. Clearly, AI opens up a whole new set of vectors, sort of reminds us a bit of some of the things we saw with databases. Things like prompt injection, and you see people doing these like weird prompts, and the models reacting in favorable ways. Once you start tying those into back ends, things can be dodgy. Anyway, we're not here to hear from me. We're here to hear from Andre Baptista. So over to you, sir. Big round of applause.
All right. Thank you, James. It's nice to see such a big crowd here in Portugal discussing so many interesting topics. So I'm Andre. I'm also known as OXACB on my socials. It's also my hacker handle. And I'm bringing you a security perspective on how we can use AI to hack stuff. And why is that important? Let me tell you a bit about my story. So I'm a co-founder of Ethiac, but before that, I hacked a lot of companies worldwide, from Uber, Tesla, OpenAI, and way more than that. Even the Department of Defense of the United States and more, on live hacking events, basically. And there are so many vulnerabilities, okay? There are vulnerabilities everywhere. And it's not a new problem, but now that we are building faster, especially by leveraging, all these LLM models and so on, and vibe coding stuff, there were multiple situations where these applications got compromised, right? Because these AI models lack some security features. It's better now, especially if you see like Cloud Code, for example. You can do a security review command, for example, nowadays when you build your stuff. But still, in sufficient complex applications, you'll see that vulnerabilities are there and that can be leaking data. One example was an application developed by a friend of mine that it was very trending on Twitter, and he built like an application for bug bounty hunters, and it was using Supabase and like some integrations, and it was leaking on a response PII, basically, from all the users, and the model didn't know about that when it was designing the system. So we co-founded Ethiac to try to scale these the capability of solving this problem by autonomously identifying those vulnerabilities as fast as possible before the real attackers do it. So let me tell you some examples about on how hacking can be improved with AI. And hacking or penetration testing, who has a penetration testing background here? Anyone? Oh, we got a few ones, nice. But I bet that everyone knows someone or some company that had security problems, right? It's a problem that still needs to be solved. Also ranked on one of the top 5 risks by World Economic Forum this year for the upcoming 2 years as well. So hackers and security researchers started to use AI in order to automate their work, right? We know how to code as well, and we build our own tools as well. So one example, and there are multiple stages in penetration testing, and the first one is usually reconnaissance. So we need to retrieve information about the target. So we need to understand what's their attack surface, what subdomains they have, what the services are exposed, HTTP, like SSH, whatever it's present on the attack surface from the target. And we had a lot of deterministic tools to do that, but now with these models, we can generate, for example, word lists. And then there are more steps. We usually screenshot like all the applications. We can run some convolutional neural networks over those screenshots. Sometimes we don't actually need like LLM models to classify those images. We can use faster technologies. And then we finally try to find vulnerabilities in those applications. We try to play with the requests, usually when it comes to web exploitation or web security research, and basically we try to find weird behaviors without having access to the source code of the target application. So in this example, I was just using like the LLM CLI to just generate a possible subdomain enumeration list for Tesla, to identify their tech stack and so on, and we can generate a list like that, basically. And then one of the steps is to try to understand what subdomains exist. Like, there are passive sources with this information. Obviously, the target knows about all these subdomains, but a lot of them, or at least some of them in certain cases, are not exposed anywhere. So you need to actually guess them, and sometimes you have access to internal APIs and more. So if I just generated a possible list, and basically I'm just trying to resolve all those subdomains with the DNS, in terms of DNS, to try to understand if any of those subdomains are resolving. And from there, we can basically just try to access those subdomains and do further testing. Hopefully the demo gods will be in my favor. So it found 1, so I was lucky, yeah. Sometimes it gives 0, sometimes it gives 2 in this scenario, so we found like static-assets.tesla.com. And there are more examples. Another one would be FFUF AI is another tool, but to identify hidden directories in web applications. That can happen after deployment, like if we use these AI models to identify vulnerabilities in a static way, like security review by reviewing code and so on. They can catch some stuff, but the complementary approach is to do it in a dynamic way. So we want to actually try to find like hidden directories that may arise in production-only environments, and one of the tools is this one to try to brute force for such directories. And there are more use cases, but the thing here is that we still need to do all the repetitive work, running a lot of tools, all the same tools all over again. This helps on expanding the capabilities that we have, but it's not enough. So what we actually started doing and researching was on building an hackbot. And what's an hackbot? It's basically an AI system that behaves sort of like me. So it's and it can be defined, this is a definition, a possible definition from Joseph Tucker. He's a very well-known hacker in the cybersecurity industry. And it's basically defined as any augmented system that uses AI in a meaningful way in order to find vulnerabilities, that mimics how an attacker would approach a given application, vibe-coded or not, for example. So there are multiple important components in such multi-agent architecture, and I'm trying to keep it simple right here, and I believe that this also applies to other types of agents, of course. One of the main components in this context is the brain. It's basically the model, is the central reasoning engine for such technology, and it's very important to try to make decisions, to test for this, test for that, and this technique and the other one. So then we have the structure. It's basically how information flows between the agents, more like engineering work, right, and not so much an AI research work. It's how we implement it in terms of using multiple libraries and so on. And then we have prompting, which is very important to give clear examples, and that's very important also in this scenario, to give clear examples of what the agents should be doing, what they should not do in certain scenarios, what techniques they can look for, and make these also extensible, like having techniques that can also be created in the fly as specialized agents, what we call also as meta agents that can be dynamically generated in certain scenarios to focus on specific tasks. And then we have the tools. Those are very, very important, especially because we are talking about ethical hacking. And we need to have tools that are capable of doing deterministic testing in multiple scenarios, basically. Thinking about like an isolated machine, like a sandbox that runs these potentially dangerous commands and is properly isolated, all right? And this really helps on trying to find vulnerabilities ahead of the attackers, and that was one of the reasons why I'm in this panel, I guess, about ethics, because we are talking about a technology problem that we are trying to solve, which is also a sustainability project. We need to make technology sustainable. We are building faster than ever, so it's really important that we make sure that it's stable, that there aren't a lot of vulnerabilities, and that we can actually trust the technologies that we are providing to our users, or even the technology that we are using. Obviously, there's a common problem in most agents, which is basically about, you've probably seen multiple examples like this, like AI agents suddenly removing the developer home folder. In the Hackbot scenario, this is even more important because we are interacting with live applications, sometimes production systems, and we need to ensure that we don't damage anything. So we need to ensure that we don't drop a table, or that we don't remove a file, or that we don't change like real data that belongs to somebody else's account, for example. So in this case, it's even worse, a worse problem than just removing a home folder. And we were able to solve that problem through three main techniques, through our guardrails that basically act on the prompt level to shape the model behavior. That's an easy one. Then we have like a LLM firewall, how we like to call it, or a deterministic filter. Those are basically rule-based checks that enforce that multiple regular expressions and so on cannot be present in the outputs from the tool calls and so on. And also in the inputs, like we don't want to actually cause any damage. And then we also have an agentic layer that we can also have in certain situations, like another smaller model that is very specific to do this kind of judgment over more ambiguous cases, assess risk, and ensure the alignment with the previous goals. So I'd like you to show how this works. And I was told that this was like a demo intensive, and I freaked out and I just deleted a lot of slides from the presentation. But yeah, so I hope it all goes well, but the scenario is this one. So we have a vibe-coded application. It's like a very simple one. I asked Claude to just generate like a PHP application that allows users to upload and list and view files, all right? And the application basically looks like this in terms of the source code. So it generated basically a simple index.php. You can see like there's a download get parameter, and then there's an upload directory, and then it actually used like a secure function to basically sanitize the download parameter, because otherwise an attacker will be able like to send a parameter like download equals like .. and like read arbitrary files from the file system, even like environment variables or secrets. So it's actually using a secure function here, and then it basically just serves the file. And then there's basically a simple source code here that basically allows users to upload the files, and it even sanitizes also the HTML to prevent potential cross-site scripting issues, right? So it's like a code that seems secure, right? And if we run some static analysis tools over it and over this code, it will basically say, okay, everything seems to be good, right? So basically what we are going to do is that we are going to run our technology. In this case, we are going to run it inside Claude, but it has no access to the source code, and I'm running it inside Claude for two reasons. One of them is just because if I was going to run The actual tool, it will basically have a big output that could be not so good for demoing purposes. So we basically use a wrapper of our own standalone tool, and it will basically try to summarize what is happening for demo purposes. And the second one is that we basically we want the cloud we don't want to reinvent the wheel in terms of trying to run the current application, okay? And like constructing the tunnel to test it in a dynamic way. So if the demo gods are with me again, everything goes well. I have a backup video in case it doesn't. So basically, it will basically just start the current application using Docker, and this is all in this case cloud decisions, and then it just starts ngrok as a possible tunnel to serve the application to the Ekbot standalone, and it will basically conduct, automate, or fully autonomous AI penetration testing over this application. So it's running right now. Yeah, I'll need to confirm some actions. Meanwhile, we can see the application. It's basically a file upload and view application, so we can try to upload like any sort of file there. So we could eventually like upload like a QR code. I don't remember what this QR code is, but we can download it. So doesn't seem to have any problem here. If we look at the requests, meanwhile, the Ekbot is doing its job in the background. It's currently crawling the web application, it's using a headless browser to try to get all the paths from the current application, what endpoints exist, even from JavaScript files, and so on. But it conducts this reconnaissance phase. And basically, we just need to wait until it finds like a potential vulnerability or more. So if we look at the requests from the application, we can basically try to understand how it works. So here I have a post request with like a PNG file, and basically if you try to download it, you'll see like a request to get download and then the name of the file, right? So one of the things we could try, meanwhile, it's doing its job. One of the things we could try would be to basically upload, for example, a PHP shell, right? So we could basically upload a user-supplied, untrusted PHP source code and try for it to execute, which would lead to RCE, right? And the Ekbot is basically coming to the same conclusions on the left. Like critical discovery, it's not so critical. We like it to hallucinate sometimes. It will try like to read the ... which is secure, but it doesn't have access to the source code. You can see also some files from the Ekbot. But long story short, if you basically send a request and you try to access shellnew.php, what you're going to see is that there's the actual PHP code. So it doesn't execute, right? So it's probably secure, or is it? So let's wait for the Ekbot to finish its job. So it's trying HTML uploads with XSS. It's trying the same PHP file upload like a human pen tester will try. It's actually uploading a file with the PHP info command right now. So it's trying to upload an HTML file that could lead to cross-site scripting at the same time. PHP files are accepted, but it just downloads them instead of basically executing them. And then it just found like a critical discovery. The uploads directory is exposed on deployment. And what it means is that we can directly access the uploads folder and basically try to access such file, all right? So it will basically just find a remote code execution in this very simple example that basically allows any user to upload arbitrary files and execute arbitrary commands on the target application. In the meantime, it just found like a cross-site scripting stored cross-site scripting as well. So we can basically just navigate to the uploads directory and visit this file. So XXS executed and then a cookie. So this is basically the output of the JavaScript that has been uploaded. Usually we could see an alert box in there. and basically it's trying to upload more files like tests.php and so on, and it will actually find the RCE in the meantime. Not sure if it already found it because it focused on XSS. It can happen. The agents do a lot of different techniques in multiple runs, but I'm pretty sure that it will find it meanwhile, but for demoing purposes, we can just navigate to the PHP shell and execute arbitrary commands as an attacker, right? So this was an example of what this kind of agents can do. It also found that we can also upload an SVG that will actually execute JavaScript as well at the same time through the uploads folder, which was a creative one. And yeah, the demo gods just put like a window in here. All right, I was able to escape it. And yeah, that's basically it. It can really help on testing applications dynamically so that you can fix those vulnerabilities before going to production and before the attackers actually try to use this. So we basically wrap this in our product. It's not like available as such a CLI right now. It was just for a demoing purpose. But in our product, basically our agents are continuously testing the scopes of our customers and trying to find those vulnerabilities before the bad guys do. So that's it. I hope you learned something new, and I'm available to take any questions. Thank you.
Sure. Thanks so much. No time for questions. So, I'm sure you're all hungry. Somehow we've gone on to Monk Chips time. So on my socials and on my blog, I'm called Monk Chips. And my events famously run late. I did not expect that this would happen at an event that I was not curating, but I believe that it in fact has happened. So if you'll bear with us, we have a couple of amazing talks before lunch. It'll be a late lunch. These things happen. You all look bright and bushy-tailed, so I'm sure it'll be fine. I'm going to get off the stage, but welcome Pedro Coelho.
Hey, everyone. Let's do a mic check. Can anyone hear me? Okay. Yeah. Good. Who's hungry? Perfect. I'll make this very, very, very short. So I'm Pedro Coelho. I'm currently Senior Director of Machine Learning Engineering at Zendesk. We have a wide range of customers, and but I started most of my career has gone around startups. I built one in 2018 named Cleverly that aimed to do AI that is scalable and useful for the customer service industry. So a lot of water has gone under the bridge since then, but I want to share with you my experience in creating successful AI products from a product standpoint, not as much as an algorithm standpoint, and also show you our Copilot products for that we're currently deploying. So we at Zendesk have been investing in AI for a very long time, even before AI was good, and creating good things like AnswerBot, which was a chatbot at the time, which I'm sure everybody used at some point, and everybody hated it. Because chatbots, let's face it, are not the best things ever. So, but how are we going to win the AI for CX race here? How will we build a product that not only scales, but is also actually useful, right? You've got a hint here in what Ramsey is saying, but let's get to it. So, who here has done machine learning or AI before GPT 3.5 came out? Good, perfect. So I'm going to assume that most of you are aware of the train, eval, deploy loop of the model lifecycle, and how things were before the advent of generative large language models. So essentially, you had a bunch of products, chatbots mostly, that would provide, the product itself would be to provision a training platform for you to feed with your data, right? You would provide examples to the chatbot or to the AI that would do prediction on your fields or whatever, and you would expect, the AI to behave okay. So effectively, you would be offloading the role of a data scientist to your customer, right? So from a customer perspective on these products, let's do a small analogy and understand, if you were a customer that would be buying furniture, right? Who here bought furniture once in their lives? I'm going to assume it's everyone. Okay, good. So from a customer perspective, why would you go to IKEA, right? To buy furniture. So it's cheap. You're not expecting top-notch work, unique furniture, but it's cheap, right? You'll have to put in the effort to assemble it or pay extra, but the quality control is good, right? Hardly there's any missing piece. And, pieces are not scratched, all the bits are there, even the tools, right? Let's say that you choose to go to an expensive furniture store. So it costs a lot of money, but it's good, and it's unique, right? They deliver and assemble the furniture, and the quality control, once again, is good. You get what you pay for, right? Now, this is where you wouldn't go to buy furniture, right? It would cost a lot of money. You have to assemble it yourself, and the quality control is dodgy. So you get missing pieces, scratched pieces, chipped, a mess. This was the state of all these products, right? They would expect you to train the LLM and get good results out of it, right? They would cost a ton because AI and machine learning and buzzwords. You would have to gather the data set, and you would have absolutely no guarantee that that would work at the end. That generated a lot of suboptimal experiences, right? There was no quality control whatsoever. Right? So let's make a bad parallel here. Let's look at the safeguards that you use when programming, when you output features that are more deterministic, right? You put a lot of effort in peer reviews, automated testing, A/B testing, various deployment strategies to ensure that you don't have any undefined behavior, because you want to control the behavior of your application, which makes sense, right? What is, the parallel to just allowing your user to supply their data and expect the AI to work? It's like user provides with their own JavaScript. That's not going to work. I mean, they can, but they need to understand that the product experience from that point onwards is up to them, right? So, when doing AI and machine learning, you have to understand that beyond the data and the algorithm, you have an opinion, pretty much like when programming. You have an hypothesis on how to build a product, and you have to steer your trained models to achieve those objectives. You cannot, look at this phrase. It's a terrible phrase, but friends don't let friends let their users influence their product directly in an unsupervised way. Or else you'll end up with a store online where people buy vacuum cleaners and they get vacuum cleaners as a recommendation of other products that they can buy. And I have yet to know a single person that collects vacuum cleaners. Anyone here collects vacuum cleaners? No? Okay, good. We're on the same page. Having access to algorithms and data does not provide with sustainable differentiation from other competitors. They will have access to data of their own. They will have access to the algorithms as well. They won't have access to your opinion, right? This made sense before LLMs, and we'll see how it does make sense in the LLM H2. Because teaser alert, it's not a training platform that you're being offered on most products, but it is access to a bounded LLMs where you control the prompt or most aspects of the prompt. That's kind of the same thing. So before we go into that, how is AI actually going to change customer service, right? There are essentially three three bottlenecks when providing with good customer service. You've got volume, you've got cost, and you've got quality, right? Some companies just forego the quality aspect altogether. We hope that's not the case. We hope that our tools will enable them to put some effort into quality, because we all know how customer service sucks in some occasions. But it is estimated that because of the automation that AI provides, around 80 by 2030, like in 5 years, Gartner suggests that 80% of interactions will be solved without a human agent in a sort of satisfactory manner. And 100% of all interactions will have AI applied to them at some point. Because when you use AI on customer service, effectively your volume, the volume of calls, the volume of tickets that you receive, stops being a problem. The AI has marginal cost compared to human labor. And human labor, when you require humans to touch every single interaction, that's where your bottleneck is. But you want to preserve quality, and you want to keep humans doing what they do best, being empathetic, and solving complex cases. That's exactly what you want them to do, right? You don't want them to resolve refund requests, right? So how are we approaching this at Zendesk? So let me tell you about the story of our automated triage, which became intelligent triage. So every ticket that comes in right now gets a prediction of an intent, which is a topic, language, sentiment, and a bunch of other internal metrics that we use to fuel our internal products, right? So when doing this for customers, this was from the Cleverly Times, we found out that admins, customer experience admins, when they were hired, the first thing that they would do to the operation would be to get new categories for all tickets. They would end up with 500 categories, none of them actionable, and some of them with 0 or 1 ticket. What we did was to form an opinion there. We formed a taxonomy of categories. All of them were actionable, and we trained our algorithms, trained our models using, large language models at the time. That was 2019. The large language model was smaller than a smaller language model nowadays. And we trained on that taxonomy. This was a hard sell, but it worked. We still offer custom topics to most of our customers. They insist on it, and then we realize that there's significant overlap between their custom intents and our predefined intents. So this opinion was a good one, and it takes away critical decision power from your customers that they don't need to have in order for the product to be successful. So enter the era of agents and copilots. ChatGPT comes out, what can we do with it? So in our operation, we have way more than 1 million agents. Like, we've released the agent copilot, which I'm going to show you, to 1 million agents. But that's not enough. We have a customer base with hundreds more agents. When we'll get to that. But 1 million agents with 5 billion tickets per year, and each agent spends 6 to 8 hours a day resolving tickets. So it's great. I mean, we can just do something like Cloud Code or GitHub Copilot that will help the agent solve these things, and it will be a productivity boost, right? And so we did. We built an auto assist that has a human in the loop. This is not an autonomous agent. This leverages the agent's expertise to guide it. It searches knowledge bases, it searches former tickets, it formulates the best answer, and it confirms with the agent if this is the right course of action, right? There's a human in the loop. It's proactive, and there's a human in the loop, and it also executes actions on your behalf if you let them, like canceling a flight, going to our customer's backend to cancel a flight, for example. It just works. But how does it work? So, is it truly magical? Well, it requires one thing from the customer. It requires the customer to define procedures. And a procedure is nothing but a policy, a set of rules. Hey, agent, when you get a refund request, you will first confirm this, confirm the email, the order number, see if the order arrived or not. So a bunch of written instructions. So looking back, right, we can still be, we can see a parallel and a problem that we have surfaced before. Suddenly, the user has total control, almost total control of the prompt. So the quality of the product now depends on how well an admin configures these procedures. Again, this is not the right place to be in, right? Everybody's buying this premise. Well, not promise, anyway. But what good looks like is still up in the air. We don't know for sure. AI and this kind of technology is very new. What we're doing, each one of us working in this problem is just trailblazing here, right? There's no standard. There's no way of doing things. And it's all about ROI. Admins really want to understand if things are being good or not. So it all comes down on the admin to configure something correctly. This is not good, because according to stats, our stats, 70% of our admins that we were inquired say that they have less than 5 hours per week to pay attention to these things. So if you add one by one, you see that this is an interesting piece of technology, the Agent Copilot. It helps a ton, but if you don't have the right procedures, it will fail. Again, not a good place to be. So again, exactly, in order to configure it correctly, you have to have Zendesk expertise, you have to have account level expertise and industry expertise on your own thing. So how do we solve this, right? Well, you know, there was a saying like 10 or 15 years ago about scaling, which was if your application doesn't scale, add a message queue, and if it still doesn't scale, add more message queue. Obviously humoristic, but the equivalent for today, it seems to be, well, if you want AI, add a Copilot, and if it doesn't work, add more Copilot. And so we did. We're releasing an admin Copilot that does exactly that. It steers the conversation between ourselves and the admin. It relieves a lot of decisions that the admin doesn't really need to bother themselves with. It surfaces information and allows the admin to make good decisions, right? It tells them, these are real screenshots, by the way. I'm going to show a video that's slightly edited, but the product works and is released, both of them. It surfaces insights and recommendations, and it makes those 5 hours that the admin has to actually look at these things valuable, right? So it also has, obviously, a conversational interface that you can use to configure the product to your liking. So, hey, I want to do this kind of automation, right? So, without further ado, I know you're all hungry. Let me just understand if, okay, good. Here's a demo.
Active AI assistant designed specifically.
Here we go.
We're excited to introduce Admin Copilot, the first proactive AI assistant designed specifically for admins. Let's say I'm an admin at a headphones company. The moment I log into the admin center, I'm greeted with a digest of key insights, trends, and top recommendations so I know exactly where to focus. Now, I'm a bit concerned about the surge in tickets due to the pairing issues. But instead of spending time piecing this together across reports, I can actually use the new conversational assistant to take action right away. To learn more about these tickets, I'll go ahead and select a prompt to create a view of pending status tickets. Instantly, I get a preview showing exactly how this will look. From here, I can approve it with one click or make quick edits before saving. Once approved, the new pending tickets view is automatically added to the views page. so I can see it alongside all my existing views. This means I'm not only spotting a problem faster, but also putting the right workflow in place within seconds. As my day goes on, Admin Copilot keeps surfacing contextual recommendations, not just in the admin home, but wherever I'm working. Here on the triggers page, I see 3 new recommendations designed to improve response times and reduce escalations. Each recommendation includes the suggested automation, why it's recommended, and the impact on my KPIs. This one, for example, highlights that negative sentiment tickets are driving escalations and slowing down resolution. I can also see all the trigger details, the recommended conditions and actions. And if I want to adjust anything, again, I can simply tell Copilot in plain language. Here, I'll narrow the trigger to a specific product line and update the auto-reply text. With one click, I can approve the trigger, and it's automatically added to my list, ready to run without any extra setup. Finally, I can also review all the recommendations tailored for my account in one place, in the new dedicated recommendations page. This centralized view means I don't just react to issues, I have a clear roadmap of improvements that Copilot continuously updates for me. With Admin Copilot, admins get a personalized digest, a conversational assistant to take action, and approve changes carried out instantly, so they spend less time on manual work and more time driving impact.
All right, so yeah, closing off, since I know you want to get some grub, remember that to build a successful AI product is a big parallel with building a good product. You have an opinion based on experimentation. You know what works for your customers. You want to set them up successfully. Having access to just raw data and algorithms won't give you a competitive advantage for long, right? You have to have that opinion, you have to embed that opinion into the models, and you have to set your customers successfully. That's what we're aiming to do with Admin Copilot, closing the loop and make sure that everything gels. Thank you very much.
Thank you so much. We've got a really fucked up situation here, right? The next talk, and we were going to push it to after lunch, the next talk is about humanity. And one of the really important things about humanity is our relationships with our pets. And our next speaker has an emergency because his pet's sick. He can't wait till after lunch. So I really don't want to do this to you. I really want to say, let's come back up, but we really want you to hear this talk. So, we are powering through on the powering through. And yeah, as I say, like emergencies, our pets, that's super important. So I'm going to get off the stage. Luis Clara Gomes, let's see us out towards lunch. Thanks for staying. Big round of applause.
Good morning. Good morning, everyone. Can you hear me well? Yeah, I think I can hear myself. I'm sorry to be the opening act before lunch. I don't like to be in this position. So I decided to make it light and maybe focus this on a tale about insurance policies. Does that sound good? Cool. Because this is the live rig I used to play live when I play with another performer. And there's a computer on it. It's actually this one. And one day, this computer broke down. So as I have everything insured, I decided to call my insurance agent and tell her, hey, Leonor, my computer died, so I need to activate the insurance. Can I get it working? And she said, oh, Luis, we have a problem because I didn't know when you sent the list of gear that you sent a computer, because otherwise I wouldn't have accepted it because the computer is not a musical instrument. And that triggered me. I found this article by Scientific American, The Computer as a Musical Instrument from 1987. And ever since, I was born in 1984, I've not been making music since then, but ever since I can remember using computers, I've been making music with them. And to be honest, I had to forego a lot of bad experiences with bad music teachers, with formal music teaching that almost destroyed my love for music. It was through computers that I found a way to express myself, to understand a way to translate what was going on in my mind into many mediums, one of them being music. And then I realized that, going backwards into what pioneers in music were making before me, I found people like Wendy Carlos that when she first came out with this record that reinterpreted classical music with synthesizers, she not only had to struggle with identity, but also as people saying that electronics are for labs, not for concert halls. This album went to go platinum. So did Donna Summer's I Feel Love, produced by Giorgio Moroder, where a synthesizer was doing the bass line. Not real music for many people. It still sparked a sexual revolution in the clubs. Susan Ciani was using bookless synthesizers, and she's behind me, but she was using bookless synthesizers developed in the 60s that were rumored to be laced by Don Buchla, the inventor, with LSD. We don't know, but still she sparked a revolution in exploratory, experimental electronic music. Autotune was popularized by this lady, Cher, with her hit in 1998. I forgot the name of this track, but it's Do You Believe? Do You Believe? And autotune became a tool for expression and for augmenting, for allowing people that would otherwise not have an amazing skill set to be able to express themselves. Autotune is a great example of computer-aided music, invented by geophysicists trying to measure the depth in underwater, and he realized that he could use it to correct pitch. So every recording you hear today, as you probably know, has been digitized in some way or form. Computers are being used throughout the entire process. It's very hard to come across any recorded music nowadays that was recorded fully analog. So it's been used in composing, in mixing, in recording, in distribution. So I have to thank the internet for having a career. Otherwise, I would never have left my little hometown. And we're living in an era of computer-aided music. I'm constantly asked in my field, how is AI affecting my field? It's the question everybody's asking me. And I think every creative is being asked the same question in their fields. And I think it's probably affecting all of our lives as consumers, as creators. It's inevitable. As consumers, we are having to deal with piercing through the noise, and this is through competing with AI slop. Everybody's seen how ugly these things look, but they're starting to look less and less ugly, sound a little bit better every iteration. So we have to pierce through these Muzak was the term invented in the 80s to describe this elevator music taken to a degree of industry. Perfectly designed for that quick dopamine hit, so is going to be the lunch after me. And how can I compete as a musician with it took me a lifetime to perfect my craft. I'm still perfecting it. I'm far from having it perfected. And how can I compete with something that you just prompt and create instantly? If a human is playing in the dark forest, do I really make a noise? Does that human really make a noise? Is anyone listening? Well, LLMs are listening because they're mining all the data we're making. At least someone is listening. It's great. All of our creations, at least someone's going to listen to make the beautiful models, the foundational models that you use. If that recording's on the internet, so this lonely recording will be part of this huge data set that is going to feed the next tool that you use to make music. So if we all use these LLMs to make art, are we creators? Are we artists? I would argue yes, that's my standpoint. If there is an intention, it is art. Some people might disagree. This banana was glued to a wall by Mauricio Catalan, and I can perfectly take a prompt and remix it and make it mine. This is my watermelon. And this raises, of course, the question of authorship. How can we trace authorship? How is it tracked? Blockchain, the previous revolution, was supposed to fix all of that. That was the great thing. Blockchain is going to fix copyright. Here we are. Blockchain is the previous revolution, and it hasn't fixed copyright. We would promise it will be a silver bullet for many things, for whoever is writing our books, taking our photos, directing our films, composing our music. I think even if we are allowed to remix anything nowadays, I think we still need to give credit where credit is due. And this was this famous test of Will Smith eating spaghetti is 2023 versus 2025. I think this is Google Veo 3. So you see how far this has come. So even if you think, oh no, it's slop, I'm going to perfectly distinguish between the AI-generated music and the real thing. The truth is, it's getting very, very difficult to tell the difference. I think in blind studies, we're only separating 62%, I think, 62% of the generations. We found them to be, we correctly classify them as AI. That's almost like 50-50, almost like a coin toss. So we're going to be it's a matter of time till all our entertainment is overrun by AI in every industry. Movies, video games, music, all of these industries will be massively revolutionized. I'm not going to be paying it. I'm not going to be a spectator. I want to be involved in it. But I also wanted to credit the authors from which we derive our works. So where does that leave me? As an artist, I'm jumping between states. I'm amazed at the multitude of things I can do with these tools, and sometimes I'm paralyzed by all the noise I have to pierce through to make my voice heard. So I'm not going to be the defensor of AI in every field of my life, but I'm going to be an adopter. I'm going to be looking to do more and more live shows, which are uniquely irrepeatable performances that have to be experienced in person, and speaks to the point that we are all here collected in a place, in a physical space, sharing an experience, because that's the only way to actually create the beautiful hormones that make us happy and feel fulfilled. You'll find me playing in the middle of the audience, creating a feedback loop between the performers and the audience, and curating the entire experience so it's immersive, from sound to light. Sometimes when we have the chance, we even curate the scent that you're smelling in the room. This is where I'll be, where you'll find me, and thank you. Have a good lunch. Through a presentation.
That was amazing. Thank you so much. And yeah, we haven't had enough talks that my daughter will approve of today. So that was the one. That's the one I'm going to have to watch with her. And she'll be like, yeah, Dad, all that stuff yesterday sucked. AI is bad. Okay, we're going to go and have some lunch. We do have some homework for you during lunch. We've had an idea, a bit of whimsy. We're going to do a one-shot prompt whimsy application building session after lunch. So we want you at lunch to think about a one-shot prompt, take an application, your favorite application, and build it, but with some whimsy. So go to your favorite platform, whether it's Lovable, V0, Bolt, Claude, whatever it is, and just give some thought to what a prompt might be that will make us laugh after lunch. So we want an app with whimsy. There will be prizes. You may well be winning a ticket to next year's Lisbon AI. Oh fuck, I pre-announced it. But there will be prizes. So have some lunch, have a great time, but think about whimsy and a one-shot prompt. We'll work it, put it on Discord, and we'll run it here. That's the way it's going to work. So go to the Discord, put your prompt in there, but play around it a little bit. See first, everyone's so desperate to eat. Go and get that food, thanks to the speakers. Where are you going, man? Where are you going? What are you doing? Where are you going? There's no escape now. So, this is the hardcore now. You're still here. This is excellent. We love this. So we did say there'd be a little surprise. There'd be some fun, I think, to close out the event. You know, we've been talking about AI for 2 days. Obviously, the capabilities have come a long way in the last couple of years. So if you want whimsy, what's more whimsical than images of humans with 6 or 4 fingers? We did actually. I don't know. I think he's banked out. We challenged Steve to compete with the awesomeness of your prompts, but so anyway, why do you keep getting off the stage, Fred? For fuck's sake. Anyway, we will now play a game, and Fred is going to lead. No? Okay. Yes, and I'm going to stand around.
Yes.
Shitpost.
Not in front of the QR code, though.
Not in front of the QR code. Okay.
For now, I assume that most people are going to be on Discord. Does this work? Yeah, it does. Good. Hello. Hi. Alrighty. So this is all improvised. We're not ready, but hopefully that's what makes it fun.
They've been working really hard to make these prompts. How can you say it's improvised? They put a lot of work into this.
Have you seen the prompts?
Look at these people.
Alrighty.
They're exhausted. They're exhausted building these prompts.
Look, we wanted to wrap this up, making something fun. We really wanted to experiment. So when we were thinking about this block, we had many ideas. One of those ideas was, let's make the worst possible applications, because usually what you get out of models these days is so polished, it always uses ShadCN, and it's, you know. And we wanted to try and force models to give us the worst possible thing. But then Noah, yesterday, gave an amazing presentation about whimsical applications and how, you know, that matters and that's how you get to people. And so we thought, why don't we try and have people one-shot something that they think would be interesting, but make it fun. And we'll do one prompt. You cannot do anything else. We'll see Claude. I'm going to use Claude. If you want to use something else, say so, but you know, Claude's fine. And we're gonna one-shot it. I'm just gonna, if you haven't seen the announcement, that links you to our Discord. Go into the announcement channel. It explains what it is. We are going to, starting in a minute, we're going to go into Discord. I'm gonna share my screen. I'm gonna do it live. I'm gonna open Claude Desktop. I'm gonna open Discord. I'm gonna paste a bunch of prompts in. The best possible prompt that gets the most reactions on Discord gets prizes. We don't know what we know what the prizes are. I'm going to keep them. I think I mentioned them on Discord.
I mean,
who am I talking about?
Oh, it's on Discord. Yeah.
Yes.
I pre-announced a conference that didn't exist yet, so.
You did?
Yeah, I did that this morning.
Oh yeah, I know. We don't want to talk about 2026 because we're all very tired. At least I am.
But you know the ha 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 sickos meme? I mean, yeah, you know the sickos meme. That is anyone that organizes tech conferences. It's people that organize tech conferences they're sickos. It's an illness.
I have that. Alrighty, okay. So, I'm gonna try this out. We have no clue what's gonna happen. If you didn't put in a prompt on Discord.
It's not too late.
No, we have a bunch though, including from speakers. So that's interesting. We'll see. Maybe this is going to be too small for you. I don't know if can I make Discord big? I can. Hopefully this doesn't suck. I'll read my example, because two people. Wow, look at that. I love that. 2 people rushed in front of me. Here's my prompt. This was going to be the first example. And I'm going to try it live. I may have tried it before, but the rules are no edits. So I'm going to paste it live.
And the prompt is, design the UI for a canvas-based whiteboarding application that shows nodes on a graph. You know about TLDraw? Yeah, Steve makes TLDraw, and he's in the audience right now. Steve likes fairies, but I prefer bats. Make me TLDraw with bats. Halloween was 2 days ago. It's actually 5 days ago. Nobody cares. So yeah, I'm going to do that. So, boom. I even added... Claude is going to do its thing. So this was the goal, right? People type in prompts. I will not, if I see people editing on Discord, I will disqualify the shit.
Were you not here yesterday? Shouldn't we have a swarm of agents doing the work? You're not going to do this in
Is
parallel?
David in the room? No. If David was in the room, I would, and I would probably try and use cursor, but because he's not in the room, is he in the room? No, it's fine. He's not watching.
Themes of the conference. You notice that these companies are like, what you need to do is to burn a lot more tokens. Weird. Like, build 15 of everything. That'll be great. It's going to be amazing.
So, this is my example. It's running. I am going to literally start copying and pasting from Discord. Unusual join activity detected in Lisbon AI. Review the alert. I'm not going to. Sorry. But
We've had talks about security today, Fred. You should care about security.
Me?
We should, you know,
Do I
we should get
consult for a security
the AI hacker to take a look and make sure everything's okay.
Alrighty. While Claude goes, I'm just going to let it go. Does it actually go if I do this? Should I open this on the desktop? Oh, there we go. On the browser, I mean. Ooh. Okay. We're going to try a bunch of these at the same time.
That was a nice prompt.
A nap to let me tape anything to a wall?
I think the lizard is the key. Like the banana and the watermelon, that's okay, but the lizard, that's what brings the whimsy.
The prompt failed. Immediately disqualified. Did not produce an artifact.
I mean, aren't these tools supposed to be better by asking us questions? Does it really have to be one shot?
In comparison.
Oh, okay. Shit, that's pretty good.
What do you think I do for a living? I talk to Claude.
Wow. Those bats are amazing.
All right, I'm going to try this out. Can I drag this?
Yeah. You're out of business now, Steve. Steve. I think he's gone, but you know, TLDraw is so cringe. Oh, there he is. Yeah, you're done, buddy. Oh yeah, we have to explain how we vote, Fred. Fred, bring me the fairies, Steve.
No. This is my prompt, so my prompt won't do. I don't want to win, but I want you guys to win. So go on Discord and write your own. But I am going to post. I'm going to copy and paste others. But as you can see, that was my prompt. This is the output. Pretty good. We're gonna see who's the best. If you're
is connect mode functional?
Steve, are you worried right now? We're gonna try and connect some nodes. Explain how we vote. You vote on Discord. You go to Discord. I'm gonna show it to you. If you like my thing, you do this. Reaction. Ignore my most used. You don't want to read this. Just do that. Okay? If you like my thing, click my thumbs up. Anything else does not qualify. It's just thumbs up. If you can use Discord, you can click a button. All right, this is what we're going to do. If we find that people vote, good. If we find that people don't vote, we're just going to give prizes out anyway. So, is that okay? Okay, so we do have a prompt.
A gossip website. Yeah, okay.
We do have one prompt here that I'm going to paste in. This is by Dana from Netlify. While this goes, I'm going to do another one. There's still time. Type it in. Did I miss any? Hold on. Yes, I did. Woogu.
Oh, the win out one. Yeah, this is nice. Wow. Okay. Yeah.
Yes. Hold on. Hold on.
Sometimes you've got to be serious about your whimsy. I mean, you gotta.
Alrighty. Listen, I said I would do it live, and I'm doing it live. While this runs. Hold on. What is
Actually,
it?
that's a
Let me
question.
actually,
Let me-
I'll
just
read
want-
this prompt because he went pretty deep.
There we go.
Hold on. Alrighty. That's cursor in big. Okay. Mission, create a browser-based music player that looks and feels like classic Winamp while offering 3 radical different skins you can switch between. The agent may choose, okay, any tech stack and libraries. Prioritize vibes, delight, and playful micro-interactions, non-negotiable. Are you in the room? Ugo, show yourself. Is Ugo not in the room?
Oh, I
He
love
has an
that.
opportunity to win the whole thing right now.
That is the way. That is the way. Just drop the prompt and leave. That's amazing.
The 3 skins.
Do you think there was AI involved in the making of this prompt?
Absolutely not. A human wrote
A
this.
human wrote that.
Do I need to
Did
say?
we say it needed to be handcrafted?
No. But listen, because he has this here, everything, and by the way, this is not about me, this is about Fred again, but I'll take it because it's my name. You know, because it has this here, I'm going to allow it.
You know, it's good. You know, it's a good prompt.
It is. Okay. I am going to paste one more, and then we're going to review. These the ones that I have to actually go in, these annoy me. You still did the right thing, everybody, but
Are you saying that people that entered the competition, they annoy you? Is that where we're at now? Thanks for coming to the conference, but fuck you. Okay, that was today. There's been a lot. I've had 4 F-bombs, I think. I'm getting relaxed.
alrighty. I'm pasting this in. Okay. I bet that some of these are done.
So should they run the conference again? Do we need it next year? Yeah?
I don't want to commit.
Next month, the monthly.
Absolutely not.
Monthly Lisbon AI.
Absolutely not. No.
That is a properly terrifying idea.
Okay. Let's do this.
And I was talking to, Nuno had been talking to Malta, and he said he'd received an invite to talk at San Francisco Tech Week. Like, what the fuck? San Francisco Tech Week? I mean, that's like having, I don't know.
Isn't that every week?
Well, pretty much. It's like having.
Is that the joke?
It's like having Port Wine Week in Porto, right? It's like, yeah, maybe we did that already. Pastéis de Nata Day in Lisbon, you know, it sort of doesn't really make a lot of sense.
Oh, it was such a good prompt and it didn't do it.
I'm actually angry now.
I'll create a delightful. What did it say? Check what's available.
Yeah, maybe it's.
Did it actually?
With no changes.
Listen.
With extended thinking, let it think longer. Think longer.
What is happening? Listen, if this fails, it still disqualifies the player, not the game.
So for some reason, Heroku decided they would build a vibe coding tool as well. So Heroku Vibes.
We're going to try another one.
And I tried a prompt, and it just completely didn't work, and I was very disappointed. And didn't close the tab, forgot about it. And it did, actually, about 14 hours later, complete the thing. And I was surprised and slightly impressed. But the look and feel, yeah, definitely not like Sheds. Oh, wow, okay.
We're doing it live. Ignore everything. You're not seeing
Make it
anything.
work.
Nothing's on screen. It's okay. Back at it.
Okay.
Alrighty. Project. Definitely nothing on screen. Trading. No, I don't do that. Close this. This is not my own. Okay.
On screen or on stream?
Both. It didn't do anything. Come on.
Should have
Claude.
used TL Draw, man. Should have used TL Draw.
Bring me the fairies.
Where are the fairies?
Alrighty, hold on. I'm gonna try this again because I really enjoyed the Winamp prompt. Both of them, if I'm honest. Also, someone's taking you out of business. The next one is a to-do list. So, you know.
And I'm interested, is anyone here at the beginning thought, I didn't do a prompt, but then they're like, now I want to do this? Has anyone gone, actually, now I am going to join in? No? Come on. There must be someone in the room that's like, I can do better than Fred.
What?
Well, that's how it works, right?
Hold on. I really want this to work, though. I'll let it do its thing. I know it's not the browser. It's just Claude. This is just Electron, right? It's just the browser anyway. I think it's the same thing.
See, I would like to see you try something with V0, because, well, Malta's not here now. But I'm not sure that Vercel can do whimsy. I'm pretty sure that Vercel is a whimsy-free platform. I'm a fine one to talk, but it's like black polo necks and black triangles. If you can get Vercel to do whimsy, I don't know, I'll buy Malta and Guillermo a drink. They're quite serious about their interfaces. Not a lot of whimsy in the Vercel universe.
I don't pay for V0. I'll have you know that right now.
Am I going to get into trouble for what I just said?
You're going to get me in trouble.
No, you didn't say anything. It's okay.
No, but I want to see
Do we
it.
think that
I wanna see it do it.
Vercel can create any whimsy?
I want to say...
Are anyone here, or any of you regular V0 users? Okay, so there's a few. Has it ever given you any whimsical results? Sort of? Ah, okay. In fact, I bet you can't even get V0 to do anything with SpongeBob. I bet you that's impossible. It's an impossible prompt in that universe.
Hold on. Oh my God. There's so many of you now. What the hell?
You need to hurry the fuck up, man. What? Yeah, come on.
I thought we were gonna have like 5 of these.
Whose idea was this? Get to it. Maybe you should get the AI to work it out. Come on. Why are you
I was here.
single point of failure?
I did say in the rules that we were going to do this for 30 minutes, but I'm going to give it an extra 10 because Claude was struggling. If Claude is down, by the way, what do we do? We'll figure it out.
Create a whimsical fairy themed card.
Would it actually generate artifacts and be good at it?
Yeah, just open it up. Why is Claude getting all the love?
That is true. This one is working, by the way. Who wrote this one? Listen, no, I will explain. We didn't want to be too opinionated and talk about and mention and use any of the tools that were on screen, just to be fair. And so we decided to use Claude because everybody likes Claude. And that's why. I didn't want to be...
What is this? You say we. You decided that. Nobody else was all... We? What is this we?
Listen.
The royal we. Come on, you got to get some prompts going. You're the single point of failure here. Come on. Okay. Enter your name. I want to see the fairy card.
Can everybody see this? What is my name? Fred.
Yeah, begin the magic. Okay. I don't know what's happening. I don't even
I don't know
what
what's
a fairy
happening.
card
What is this?
shuffle
Okay. I promised I would read it. I will. I'll do it.
But the
I'll do
little
this now.
animation, that's got whimsy right there. Shuffle the cards. What cards?
So we're at a conference and your task is to make a small app, really contrived example of the Whoa. Okay. As you can make it, people write their name, bang their ticket. You shuffle 3 cards, including the ticket. Something, shuffle the cards. Okay.
Okay.
Pick a card. You pick a card. Hands up for 1. Hands up for 2. Hands up for 3. Okay. That was too quick. It was 2. What do we do now?
That's amazing. I don't even
Fred
care.
won a mystery prize.
Live
Okay, what?
concert ticket. There you go. So someone gets a free ticket to see Luis play. Huh?
Fine. Listen, Claude was not too bad at this one. I'll do another one. Hold on. By the way, if you're into this, remember, thumbs up right there. I'm going to do it.
I didn't know that we were going on to the dumbest timeline this afternoon, though. This is quite something. I'm loving it.
This is 5 kilo. What are you? Alrighty.
Rachel Lee, do you want to fire up Quen and start going through some prompts as well? Please.
While this one runs, and Rachel Lee opens up.
Yeah, we need more
Goose
prompting happening.
with Quen. Hell yeah. Let's go. By the way, this prompt is also working. Cool. Okay, while it runs. Who is this person? Are you in the room?
And I love the way we got whimsy by
Nice.
saying whimsy all the time. It's like if we just say whimsy in the prompt, then that's bound to work.
I don't know what's wrong with my trackpad today, but oh my God. Does anyone enjoy macOS these days? I do, but still, you know? I wonder if this was pausing because I was switching to a new...
I like there was trust and safety in that prompt. Someone said, don't be mean to people in the prompt.
Was it actually there?
Yeah, it was there. Somebody had seen Rachel Lee's talk and was like, yeah, we need to... Was that yours, Rachel Lee? Okay. No, it was not. Okay, there we go.
I'll create a... So I want to read this prompt. Is that okay? You're an
Honestly,
expert UX developer specializing in creating delightful, emotionally engaging web applications. Your task is to build a whimsical to-do list application that responds to user actions with distinct visual and animated feedback. Creating a joyful interaction. Okay, okay. Be honest, did you use Claude to write the prompt for Claude? Is that a yes? I can see it. It's fine.
Whimsical to do.
By the way, who knows what's playing right now? You're cheating. No cheating. Nine Inch Nails is the soundtrack for the entire conference because they have one album that is Creative Commons, and we decided to use that album. He decided to use this album, by the way.
So this brings the whimsy to you, because you got to think of something magical you're going to do.
Let's see if this puts Todoist out of business. Put Todoist out business.
You've got this. Wait, come on. That was okay.
Okay.
We need more magical tasks. That is amazing.
Hold on. I'm in front of this, right?
Oh.
Get it to what? Postpone? Okay, another one.
Is this you, Bidu? Okay. Yeah, that is so good. Oh.
And what happens if I click this?
I think I need this app in my life, actually. Just hit the URL. That one's that's a keeper.
Okay. I like this one. If you like this one too.
Send it to my phone.
Boom. Right?
Yeah, oh no, that's
nice.
Okay. If I was on Discord, I'd be picking that up right now.
All right. I think this copied and pasted. We're gonna do like 5 more?
Yeah.
Okay. What, while this runs?
But I mean, am I going to do thank yous after? People might, I mean, the more people leave, the less value the thank yous have. Shall we thank the organizing team for the conference? I mean,
They're thanking you.
Shall we thank the speakers for the conference?
Yes.
Shall we thank Lisbon for being really awesome? shall we thank our valued sponsors who've helped to make it be a thing?
I just read crying animation, so I think the Claude is just going to repeat this. Is this? I'm not pasting the same prompt, right? But it is a different one. It is a different one.
Wow,
This
what's
one is
the-
also a to-do list.
What's rendering Windows 7? I want to.
It's a different one.
The next
we'll let
prompt
it
looks-
we'll let it run.
Okay.
But while is it the same? What are you doing? I'm
They
doing
did
this.
it twice. It's normal. If you want to win a lottery, buy more tickets.
Okay. Okay. So it's a different prompt, right? I'm not messing this up, right? Okay, good. Okay.
What? Come on, the Windows 7 one. We gotta
You
move
gotta
to the next.
split the prize. If you win.
Yeah, come on.
Okay. All right. I'm gonna. Okay.
Okay, that's good.
You have my attention. Hell yeah. It. Because I wrote later. I clicked the later button. It's just
Fred,
shaking really hard.
Next prompt.
Next prompt.
Yeah. You're just playing the game.
Sorry, guys.
I mean, Windows 7.
No. But I was gonna ask something. Did I actually? Did I miss this one? No, this one. This one was the one that was just on screen, no? What the hell? I think it's Discord kinda making this go crazy. I know what to do next. Okay, nice. Sorry, thank you. Sorry. Okay. While this runs, I did mean to ask a question. So, it is hard to make a conference that is supposed to work for everybody. We probably messed up in a million ways. Please send us feedback. We're truly, well and truly listening. So, if you have immediate feedback right now while this runs, please shout it out while this runs.
Yeah. Yeah, no, that's fine.
The feedback? Right now. Shout it out.
So I had a weird thing today that I didn't fully realize. So, I thought I explained what I did yesterday, and then the first question they say, what do you actually do? Like, other than introduce people at conferences. So my name is James Governor. I run a company called RedMonk. We are a research company that helps anybody that wants to understand how to work more effectively with software developers. So my day job is just understanding, spending time listening to devs, seeing what they're doing, trying to be part of the conversation so that we can help people be smarter about the decisions they make regarding infrastructure. Have you all heard of a company called Gartner Group? We're the opposite of that. So they're top-down purchasing and procurement-led. We help people understand engineering-led decision-making. Now the thing is we ready to go with this?
Go.
Well, the thing today that is kind of interesting, so I've written a book, and what I didn't realize is that actually it's published today. So, I've been busy with a conference.
James, myself, a bunch of people walked up this morning. We had an event on Discord. Some of you may have seen it. We announced it via email as well. As we were walking up, James was saying, oh yeah, my book comes out next week.
Next week. I thought it came out next week, but apparently it's today. So the book is about a concept called progressive delivery, which basically takes a lot of those concepts we've had from CI/CD, all the stuff we worked on. But look, when those books were written, when those ideas were written down, the cloud wasn't here. A lot of the technologies we have today around automation weren't here. So in a world where we need to experiment more, there's so much automation, we have to do A/B testing, we need to think about applications from the user's perspective. That's what the book's about. And so yeah, if you've enjoyed my rantings in the last couple of days, you might take a look at the book, Progressive Delivery, published today. And the really annoying thing is we started the book literally before GPT hit. And by the time it takes, books are not like, I mean, the book is about progressive delivery, but it's very hard to add new content. And it's probably somewhat out of date because of the kind of crap that we're seeing right now. So yeah, these are not great examples of progressive delivery. But yeah, I'm publishing a book right now.
Congratulations. Can we thank Steve, by the way, for being, James for being here, by the way? Steve right there. James is awesome. He's also committed to do this next year.
I think.
You did commit me to run this next year.
I mean, I say a lot of things.
Okay, so very quickly, this one, I'm trying to click, it doesn't work. Disqualified. Are you in the room? The person who wrote the... I'm sorry. Oh, well, it doesn't do the thing. More QA.
Yeah. See, progressive delivery would have solved those problems. A bit of testing, effective rollback mechanism.
Okay. Hold on. We're doing this.
Rachel Lee, did you just say I'm not going to do anything with Qwen? I'm too busy doing... Okay.
It's going to space.
Is that, what's that craft activity that you're engaging in there? Embroidery.
I'm the one cheating right now. I'm not using the Wi-Fi. What is it doing? It didn't even create an artifact, guys. Disqualified.
I was really looking forward to that Windows 7 desktop, man.
It's just going. Okay, well, 2 more. We're gonna let it run, because maybe it fixes itself.
It would have worked if it was Windows 3.1.
Copy text. I'm gonna edit the prompt. Alrighty.
Is there like booze after this? Why is it not? I mean, I feel like it should be now. I mean, we need to grease the wheels a bit.
What's happening?
Wow.
I mean, it's just prompt engineering, guys. This person asked for an actual HTML file. Make it in line. Hacking the system with a better prompt. Not disqualified yet. We're gonna let it run.
What?
No, I said not disqualified. We're not disqualifying it yet. But I want to check on votes. Currently in the lead. That guy. After that guy, we have you, I think. Right? Ricardo, who are you? Is Ricardo in the room? Oh, that's also the friend. I see. You're losing to your friend. Okay. Well.
More prompts. I think so. We need more prompts. But Fred's just really slow. He hasn't had enough.
No, I'm literally just taking it slow because Claude is taking it slow as well. I don't want to do 2 things in parallel.
I think that there are more organizers. Get those laptops fired up. Well done. Yeah.
Build it now, no questions.
And in fact, anyone can go in the Discord, grab a prompt, run the prompt, and then we can plug that in if the app does a thing. So we can tear through. You are my swarm of fairies. You are my fairies. So yeah, if you've got a laptop, the prompts are on Discord. We can run more prompts. That is a possible thing.
It's still going. Wait. It just closed the HTML. Hold on. It's thinking. Maybe. It's not generating anymore. But the artifact is not showing. Disqualified. I mean, Quen did not work. Alrighty, we're gonna do one last one. We're gonna do one last one because I want James to hop back on stage, close the sound for the day. I want you all to go home.
That's going to be really quick.
That's okay.
There's not much closing down to be done.
One last one.
I think it's the...
So, two last ones?
Oh, and you know what? Like, so
the last one, you want me to... This one. You want me to run this one? We have 50 minutes.
Another thing, Fred, is this weekend, you can go home and you can... What day is it? It's not even the weekend yet. What? I don't even know what day it is. It's Tuesday. I was thinking it was Friday.
This is how James finds out that it's a Tuesday and his book is published.
I've got my whole week ahead. But also, if it was Friday and it's my wife's birthday tomorrow and I have not bought a present yet, I would be in the shit. So I'm glad it's not Friday, even though my brain just put me into Friday. Yeah, it's weekend No, that's not how it works. So you can, when you get home, you can sit there and do all of the prompts, set up a web page, build an app for that. Amazing.
You're doing a bunch? Okay. Yeah, this one was... Why did it not work though? Well. Say that again?
I'm not sure this is a very good advert for Claude at the moment, you know? Did you throw a whimsical prompt into V0? Were we able to establish whether it...
I don't think it did it.
Yeah.
This is the one that I skipped? We'll do it. I'm actually gonna copy it because I'm not sure that clicking this is doing the thing. Yeah, GPUs are going crazy right now. While they do, I really don't want to click this.
Create a whimsical app with fairies, unicorns, and animated pips. I will be able to move them.
It's taking so long.
On the screen.
I'll trust the system. Here we go. Let's go. What's happening, Rachel Lee? Oh, is there? You shared the artifact? No thread. Is this one it? No. Go back to where you were, he says. Yeah. Here we go. Be afraid. We're gonna run this. We don't care about the error. We're gonna run this.
I would like to know if anyone's ever said they wanted animated poops in V0.
Okay, so
I mean, it has now.
I can. This is me.
Okay, it's not super whimsical, but it's very functional.
Hold on. Oh,
that's amazing. This is the future. Now Fred's just going to play that for the next half an hour instead of doing more prompts.
No, but the thread was a good idea. I appreciate that. I will thumbs it up. It was at 15:05, so a long time ago. That gets my thumbs up.
Vercel is building me a physics playground for my animated poops.
This one also didn't work, by the way. Didn't produce an artifact.
How's Quen doing there, Rachel Lee? Oh, wait. Add fairy, add unicorn.
So, this one is supposed to work, but it didn't. Disqualified, I think. Oh. Hold on. What? Yeah, it is the same. It finished. Watch what happens when I hit space. Claude is really good at this. Look at
That's amazing.
It does look sick, but when I fire, hold on, it teleports. But it is qualified, I guess. I like it. Okay. Hold on, let me just copy and paste this one, just so I don't mess up. If you see me skip anything or F this up in any way, please let me know. Cursor 2.0 failed? 3.0? Oh! I was like, wait. I see what you mean now.
So what is this application?
We are now. You are an expert US. Why US? Fine. FinTech engineer, compliance analyst, build a local first app called Kidroth.
Wait,
I see.
what? Where is the whimsy in this? This is seriously lacking whimsy.
You don't like finance? You don't think it's fun?
Finance is not fun. Definitely not. Unless it's if you're new, finance is fun, but for normal people, not so much.
Okay. Okay.
But you know, mate, this is probably worse than waiting for builds, man.
Deliverables from Claude. A multi-file code listing. No. We're never gonna run UV. This is not gonna work. It's disqualified.
One last one. You're running, okay, two last ones. I keep expecting people to just be like, I'm out, and actually some of you are really still here, which is just amazing. Human beings are amazing. They will put up with all kinds of shit.
Are you?
Whimsical physics playground.
Did you do this just now?
Add poop. Oh yeah, I've got a whimsical physics playground with V0. Actually, you can add poop if you'd like to, or would you care to add a fairy or a unicorn?
Do you know who wrote the prompt? No, but it is one of the prompts.
Okay, we've got a whimsical physics app. It turns out that Vercel is not as serious as I thought. Yeah, there you go. Got a bit of Vercel animated poop.
So this is cheating. What's happening on screen right now? Because
Anyone
Rachel Lee used
do some,
Lovable.
animated poops.
However, it is. What's with the owl though? Oh, it's because
I
it's
did not
spines.
expect that. I thought it'd be like, no, it needs to be all in black.
I see.
And very crisp.
Begin your transformation or surrender to the owl. I surrender to the owl. It doesn't do anything.
That's amazing.
I guess I'll begin my transformation. It doesn't do anything. It
So
doesn't
this
do
is
anything.
awesome. Vercel is way more powerful than I realized. Look at that. Look at those fairies.
Who wrote this?
Me. I cheated. This is my entry. There's too much poop now though. Nuno's been here.
You need to share this somewhere so that I can show it on screen.
Okay. Well, how am I gonna do that?
I don't know.
It's great. I love this.
Who the hell wrote this prompt? Today's enlightenment quest, path to self-actualization. Confront your deepest fear or just do 5 push-ups. James?
What's that?
5 push-ups.
I'm going to do 5 push-ups. Why is it me?
I mean, I'm staying put.
I don't think I'm going to do 5 push-ups.
Manifest abundance by checking your bank account. Certainly not now. Achieve inner peace through aggressive self-improvement. Okay, so this is real. Is that yours? No. Okay. So this is real. Yesterday I could not sleep because I was so stressed out because of the conference, and I actually legitimately had to put on sleep meditation, and I fell asleep to it, which I guess worked. But I have one more. Okay.
Yeah,
Is it?
No, you can't drag them. I didn't say draggable, but you can drop them.
Okay. So, okay. I see it.
Pretty simple prompt. It's cute.
Aw.
This is
Stopping
V0.
emoji disqualified.
Who knew?
This one worked though.
Vercells, yeah.
Disqualified.
Yeah. Wine therapist.
So this is the
This
last.
is what I need. Okay, now you're talking my language.
This is the last one that we'll show.
Okay. Get a wine.
We're
to
winging it
actually-
too hard, and Claude is struggling, and we don't want to keep you here if Claude is struggling. The wine therapist.
What's weighing on me is that I'm not done yet.
What do you mean? You're not.
That's my prompt. I'm not done yet. What wine do I want?
What's weighing on you?
I'm just going to add some more poops. So good.
It recommends champagne. I don't do alcohol.
Do you want to
but
add some poops?
Why not? Why not?
Yeah, drop. There you go.
New session.
Absolutely.
I like that it's starting
I'm
to,
collecting poops.
It's trying
Poops
to
and fair. Oh.
coach me into
hang
drinking,
on.
which I don't know if I agree.
That's interesting.
I'm into it though. Do we have one more, Gonzalo? You're disqualifying a bunch of people, Gonzalo. Alrighty. I'm gonna call it. Can I call it? Alrighty. Guys, I do think that looking up, people tried, and I really do want to give out these prizes because we have them, they're here, and I want you to have fun. Yeah. We'll hand them out. That's okay. Yeah, we'll do a few more minutes to vote. The problem is people have to scroll up quite a bit to find the ones that we did run on screen. But if you want to thumb them up or thumb them down, I guess. Yeah, go on Discord, do that. We want to wrap this up.
I think if you've got WhatsApp on your machine, you could see my poop app.
Do I want to open
I mean,
WhatsApp?
you know, you could. I've only seen it on mobile. I don't know how it works on. Oh, it's okay. Chat's private.
Disqualified.
Disqualified. Oh, boo.
Alrighty, no, but we'll do that. We'll do that. Please thumbs up a few things if you like them. Really, this was meant to be fun. Claude obviously struggles. There's a lot of work to be done. If you're an engineer, you're not out of work yet. No. No. We want to wrap it up. I want to thank you all for being here. James, you can close this down in any way you want. I think you should be talking about your book because you're.
Well, I did that. So I've done the thing. I've like hustled and grifted and all that stuff you're supposed to do. I've recommended that people might enjoy my book, but it's not about me. It's about all of you. I think as I said yesterday, it's just so great that there's so much innovation and so many cool people building stuff here in Portugal. I think that's the key thing. It's about, I think so many of the events that we go to, and there's been some of this at this conference, to be fair, where, I think too many tech conferences, we sort of end up celebrating Silicon Valley. But actually, that's not where all the builders are. The builders are like everywhere. And certainly for me, as somebody that I just love Portugal, love Portuguese people, it was a privilege to be invited. You're clearly doing a load of amazing work in AI. There's all sorts of interesting people and examples I've heard from over the last couple of days. I think one that's really stick with me is Bruno Suarez. And when I met him, because I'm so used to meeting people, I'm doing a startup. I'm working in a fintech. I'm working at a crypto company. I love all of that, that's fine. But Bruno is literally an oncologist, right? He is there on a daily basis helping people with their medication and their cancer care. And he's here because he wanted to learn about how we can improve cancer care using AI. So being able to, so that patients can basically talk about their symptoms, because the thing is, if you give these medications that are for cancer tend to be very, very aggressive on the body, and sometimes that actually hastens the worst outcomes. And so having a better sense of medication and how that can be managed. And so yeah, there's a lot of naysayers about AI. You're here because you're not the people saying all AI is bad. But I just love the fact that someone here in Lisbon, he's an oncologist, and he's found the time to come here so that he might be able to have better outcomes for people with cancer. And like, that to me is the much bigger picture than poop apps and stuff like that. So keep building. I will come again if I'm invited again. Yeah, it was a great conference. I think we've done the thank yous, the speakers, the sponsors, the organizers. And so what I would say is just thanks all of you for coming. Oh, and there has to be some booze now. So there's, yeah, let's break and have drinks. Cheers all. Oh, I'm done.